All right, everyone. Welcome to Call for Code Fridays on IBM Code Live. I am Spencer Crone, developer advocate at IBM, and I'm joined by
Justin Halsall, also developer advocate at IBM.
Where do you live, Justin?
In New York City, actually in Brooklyn.
Okay, we have to be specific. Like, is it Williamsburg or?
No, border of Park Slope and Prospect Heights.
Okay. So for the three people who know what that means, they're all very, very angry. So what we're talking about today, we're going to do 4 hours of streaming today on Fridays. We're trying to do this every Friday as a way of enabling people with Call for Code. So what is Call for Code? Well, if you've been on the stream before, you've probably heard us talk about it. But basically, Call for Code is a distributed hackathon for greater good. And so it's kind of an independent project. It's a partnership between IBM, the United Nations, the American Red Cross, and a number of other smaller organizations. They're all coming together that says, like, hey, natural disasters are bad and they're problematic. You see that all over the world. Can software be leveraged there? And so the idea is you bring a bunch of technology together, you bring skills inside the UN and the Red Cross to actually deploy those technology solutions for a future natural disaster problem. And maybe this enables people to help each other and that worsening to be lessened. And to make it all fun, there's a $200,000 prize for the winning team. So what we'd like you to do is go to callforcode.org, smash that register button, and we'll get you started. There's a ton of enablement materials. That's part of the stream here. In just 30 seconds or something, we're going to be talking about technology again. And hopefully you can roll some of that technology into your Call for Code submission or use that as a getting started. If you press register, you get access to the Call for Code Slack, where there's a number of, for lack of a better word, like tournament organizers that can answer all the questions about, like, how do I log in? How do I get registered? Blah, blah, blah. If you have other questions, you can ask in the chat. Someone with the little mod sword can tell you how to get started and how to register and what the rules are and stuff. But the TLDR is $200,000 distributed hackathon, build a team, solve a problem related to natural disasters. There are some rules around that. There's a published UN list of what constitutes a disaster. And so you kind of write some software that can help with that in some way. And we'll have people on throughout the day. And there's plenty of stuff in our replays and our videos on this channel explaining, kind of what that stuff is. So Justin, what are we talking about today?
So today I would like to show you something that I've been wanting to get into for a little while, and it's a programming language called Crystal. And it's the tagline is fast as C and slick as Ruby. Now, what they did here is Ruby has a really nice syntax, and I really love working with it. Have you worked with it before?
So let me give everyone my short biography, right? I spent a while in the operations scene, which is why you have me on here doing Kubernetes, Prometheus, and stuff like that. But what that was a few years ago was Chef and Puppet, and so there was a lot of Ruby writing in that, and Sinatra apps and little plugins for Puppet and all these things. So I've definitely raked many a time. I've done a lot of fixing gem files that break, and a lot of kind of the release management around an open source community called Vox Populi, which still exists on github.com or github.com/voxpopuli.org. Vox Populi. We have, I think one time we had something like 300 repos there. They're all some amalgamation of Puppet code, Ruby code, and utilities. And we did a lot of work around making sure that all the tooling was the same, all the gem files were in sync, all the dependencies were there. So I've written a middle amount of Ruby, but I've installed Nokogiri way too many times.
Yeah, it's a great little scraper, Nokogiri. I love it. Well, my first experience with Ruby was going from PHP and then just stumbling on Ruby blogs, I think via what was the JavaScript framework again?
That's a bingo game.
And I think it was because of Scriptaculous back in the day.
Okay.
And there were lots of Ruby examples, and I was thinking, what is this? What is this? Is this PHP? It wasn't clearly. And I really loved the syntax. I kind of got into it, and then found out that I really enjoyed that, and I never wanted to go back to PHP at that point in time. Now, this was a long time ago, but it's
oftentimes there's kind of two ways people get into Ruby, right? Like they found some reason to write Ruby, or they came in through the Rails hatch. And that has created kind of a situation in the Ruby environment, because Rails, for anyone who doesn't know, Ruby is a dynamically typed programming language it's an interpreted programming language. Rails is by far the most recognizable instance of Ruby, right? It's the standard web framework. Books are on Ruby on Rails. Ruby on Rails is a thing. There's books on Ruby on Rails. There's tutorials, there's videos, there's entire careers and companies and agencies and everything with Ruby on Rails. And then what Rails actually kind of did was extend the syntax quite a bit. So if you were a Rails programmer and you tried to go down to just like straight Ruby, Stack Overflow is full of like, how do I do basic thing?
Yes.
So which did you come in through Rails or through like Ruby?
I came in through Rails. Yeah.
Okay.
Yeah. And then basically realized that I was falling in love with Ruby programming language, but I didn't know what Ruby was. It was just Ruby on Rails at that point in time.
Yeah. So that leads us to Crystal.
Yes. So what they've done with Crystal is, a lot of people know that Ruby is not really fast. It's quite slow, especially compared to a lot of other languages, and it's very much optimized for developer happiness, especially with the Rails framework there as well. And it being so slow, it's kind of one of these things where if your application gets quite popular, you have to start working on caching and all that kind of stuff, which always sucks. What's the old saying? The two hardest things in computing are naming, cache invalidation, and off by one errors.
Right.
So cache invalidation being one of them, you're kind of like, it's not fun to deal with. So what the people behind Crystal have done is they've basically used just the Ruby syntax, created a compiled language, and added things like a whole type system to it and some very interesting new constructs and stuff like that to make it really as fast as C, but allowing you, if you have a Ruby background, to just basically bring all of that knowledge to the new language and be able to basically run with it, which I think is quite cool. Okay, so is it a compiled language? Yes. Yeah, okay. Compiled. Yeah. We can check out the website. So actually, before we check out the website, I was thinking, I've never really done anything with Crystal. You've done a little bit with Ruby. I've done a lot with Ruby. We've both done enough with Ruby. We should be able to start working in Crystal. That was my idea. So we're gonna see if that works. Yeah, we'll see. Yeah. So, and the other nice thing about Crystal having the Ruby syntax is that they didn't really need to design any new syntax highlighters for it, and you can port a lot of Ruby packages quite easily because the syntax is pretty much the same, and all of that good stuff. So I thought it was quite a smart idea to basically grab the strongest part of Ruby and the worst part of Ruby and try to fix that and create something new, basically. And I think you said either on this chat or in our lead up to this that it's a statically typed language, right? Yeah. Or strongly typed. Yes. So it has its own type system. So this might as well. We'll just see how that gets. We'll see how it gets. Yeah, exactly. But every time I've seen like a type system, like Python is a good example, like just kind of bolted on to a dynamic language, I'm like, this isn't fun. More fun. This is less fun. But let's see where we go. I know static type languages are all the rage. So we're gonna see now if it worked in this case. Yeah. So let's look at the syntax. This might as well be Ruby, right? Yeah. What does that look like to you? The block there with the brackets? Yeah. Like this is very, very Ruby-ish.
I mean, you used to have the same Ruby string formatting. I see that. Mm-hmm. I see liberal use of white space all over because why not?
Mm-hmm.
Even the end statement puts. Yeah, this is pretty. Yeah, I bet that does that run if you put it in Ruby. Might.
There might be a package that you could require that is just an HTTP server. I'm not sure.
Yeah. Certainly, if you change that require line, this would work.
Yeah, totally. Or you could write your own thing. That this might as well be Ruby. I don't think there's any difference here. So they've really kind of used the Ruby language, Ruby syntax, and then check out the type system over here. So this is kind of how they do it. They infer a lot of the types from the code that you have, which is kind of cool. So let me see what's going on here. So so you're allowed to mix types depending on what you specify.
Mm-hmm.
I can maybe show some more examples. We can
docs request docs pull request welcome. That's what we're here to say.
Yeah. Let me see.
Did it really just take you to the Wikipedia page on functions? Because that's awesome.
Yeah. And then this is types of method. Oh, okay. I think I have to go. Oh, right. Okay, that wasn't clear. Everything's an object. That's the same as Ruby. Perfect. Let me see if I can get some examples.
So it's kind of like you just fill in all these responses, like 2s length. All the if you want it to behave on certain operators or in certain contexts, you just sort of fill in all these methods on the object or on the class.
The same as. I mean, that's the same as Ruby, right?
Yeah. But
so
I don't exactly see where we have type enforcement of any kind.
Right here you specify the types basically, but in this case you could actually leave this off because it would see that because you specified in the class that age is 0. It would see that age is an int, and if you try and change it to something else, then it would start complaining. Let me see if they have a nicer example of it. This is really basic stuff. Yeah, here, look, here's you can basically, when you call a method, you can say what kind of type it is. And then it would start, when you define it, and then it would start complaining on compile time if you're trying to put something else in there. So that's kind of how it works real quick.
So here's a question.
Yeah.
So let's go to that.
This one.
Initialize. That's a good example, right? So when we're validating, we're basically saying that whatever we pass to this, it's just going to be the make a new person, right? We have to have a name. When we pass something to that, are we actually saying we have to pass in a string, or are we saying we have to pass something that could be any object as long as it responds to 2s?
No, it has to be a string. Yeah.
Okay.
Yeah, and one of the things, because of course there's a lot of inheritance going on in Ruby, so I think you can specify string plus, and then it will be everything that was inherited from string, basically, or that inherits string. Yeah.
Got it.
So I think. No, where is it? I don't know. Maybe I'll find a quick demo. No, that wasn't it. Oh, this is actually quite cool. This overloading stuff.
All right, we'll see if my brain can actually pack all this in.
Okay. So here we have some types or some variables that it sets initially when you create the person. And then there's different methods that you can call on it. You can overload the same method. So you can have, these two methods, basically in plain Ruby, they would just overwrite and it would just be the latest one. But here, because we have, and actually, let me show you a different example. Here, this is even better. So this one has a method that responds to the int.
Sure.
And then this method responds to string, and then based on what you put in there, it calls the different one, which I thought was kind of interesting.
Yeah.
And then you can call become older just without anything, and I would call this one, or you could call it with specific types, and then it would go into that. So I thought that was kind of novel. Yeah. So that's kind of the type system. So they have some null reference checks, which the idea is that you spend a lot less time debugging, which especially you called null, or this and that method does not exist on
no
null.
Method,
it's like
nil for nil.
That was it. Yeah.
No method nil for nil class. It's like, well, cool, generic error.
Yeah. It's the bane of every Rubyist's existence. So they basically give you some errors at compile time where they're like, hey, this could be a nil, which is nice. And then they have macros, which are
so if we go back up, that's at compile time.
Yeah,
that's not at evaluation time.
No,
and so it's sort of just, like, how deep is this evaluation? Is this just some compiler checks for hey, we're fairly confident this code will never be executed, so this won't have a value, so blah.
I'm not sure, to be honest.
Yeah. Well, once we get on the command line and we start playing with it, maybe we could construct a couple test cases to see, because obviously if this is comparing to input, it'll have no idea.
Yeah.
Anyways, go on. Good stuff. Cool stuff.
And then macros I haven't really read up much about yet.
What? There's Jinja in my... Oh, what? Okay. All right. We can combine bang defines with Jinja and call that a thing. Why not? Let's go.
Yeah. So that I haven't touched yet. I haven't really read up about it.
We don't need that yet.
No, that's advanced stuff. And then they have fibers, which is kind of like Go and Clojure, kind of adding in some new constructs into the language, which in Ruby are hard to do, or I don't know, feel kind of
interpreted languages.
Yeah.
And so is that where you think, because one of the things we led off with, one of our headline, marquee items was, speed. So is it, so it sounds like we compile down to something that's machine readable. So we avoid some of the interpreter slowness. And then we also, it sounds like we're adding a concurrency model in green threads so that something that's a little more business code can run it at scale. Is that the TLDR of why it's fast?
I think so. Okay.
Yeah. All right.
I think it is. I think that's the yeah. And then they also have C bindings, but I hate C. That's why I like going to other languages, which are nicer than C. But
this looks pretty disgusting. But as a Python programmer, there were a handful of times when we used either the C FFI or the F FFI, which, if you're wondering what that is, that was the Fortran foreign function interface.
Yummy.
And if you thought that maybe you were too cool for that, anytime you use NumPy, bro, it's calling out to Fortran. So we found that out once when we were doing something. We were mistakes were made, and we had to compile our own NumPy. And we went down the train of we have to compile this Fortran stuff to compile this NumPy. We're all right, maybe we'll make a different plan. But it's nice that as an I don't know if this is inherited from some generic FFI or if this is just their C binding. So if you have something written in C, you can bring it in. I can't read this at all, so I have no idea what it does.
But neither can I, which I think might be I don't know. I'm not going to bash C. We're good. Cornerstone of everything. And then they also have dependency management, which is good.
Interesting. Yeah. So this is the cool thing about modern languages, right? Whenever you write a language now, you also tackle the challenging problem of dependency management and tooling, right? Whereas the kind of first generation, your Perls, Pythons, Rubies, and maybe JavaScript, like kind of was the Wild West where there were competing package implementations.
Oh yeah.
I'm very excited to, once we drop onto the command line, to like play with this thing a little bit, because, as kind of a deploy guy and a release, I've had that release engineer hat a bunch of times. It's interesting to see what's going on. Distributed via Git, obviously that's, if for anyone who's played with Go, that's like pretty common, but has some questions on it. So interesting stuff.
Yeah.
So there's also, and I don't know if we want to talk about it now, we can either go on the command line and write some like hello world stuff, or we can talk about Lucky.
Yes. Yeah. Let's do a quick chat about Lucky.
Okay.
And then we'll go back into Crystal. Perfect. But basically there's a couple different competing frameworks, because it's a new language. And I think there's Amber out there. And then there's Lucky, and I think Amber might be a little bit more like Rails. And then I think the idea behind Lucky is to be a little bit more native to some of the nice things that Crystal has.
Yes.
Which I think is kind of cool, and that's why I wanted to try out Lucky, not so much Amber. There might be other frameworks out there. I'm not sure. But yeah.
For me, I'm generally, whenever I'm picking something up, I'm always looking for like the Flask alike, or the Sinatra, or the Express, because those are just so, it's a smaller programming language that fits my smaller brain.
Yeah, that helps. That does help. And then kind of this is some of the syntax. You can check out what it looks like to create a database. This is somewhat different to Active Record, but similar-ish.
Sure.
And then let me see. I believe they have their own layout.
That's wild that it's just like HTML in there.
Yeah, it's kind of crazy. Yeah,
it's just like inline kind of templating.
Yeah. But then also functions. So let me see. It's rendering the index page. So that's this.
So the page is a class, and the class has like a handful of magic methods you just populate in, like content and whatever. This is like, as opposed to calling like blank.render and return that to some, write it out function. Okay. All right.
Yeah.
And
UL is definitely
just a function too. All right.
UL is a function.
And then that class is probably the CSS.
Yeah. I think so. Yeah.
All right.
And then links to the object, I believe. Yeah.
Yeah. The link stuff is cool. I was looking at that last night.
Yeah. So this is definitely different than anything I've done before.
Yeah. Begging the question, like, what is that bracket doing? Or is that just like compressing it into one line?
This one, you mean?
Yeah.
Yeah. So it's like here you have a block.
Yeah.
Wait a minute. Yeah. So it's just the same. It's the same as this and that one, but it's just having it on one line, so you don't have to have this endless nesting thing. Yeah.
Sure. Okay. All right. I mean, that's slick. One of the things I read in the docs yesterday is that they've done a lot of work to like kind of, probably in relation to the compiled and those pre-flight checks ideas from Crystal, is that when you do this kind of link to thing, they actually inspect like, well, what kind of HTTP verbs are on the other end of that thing we're linking to? So like if you're intentionally linking to something that is only the delete user or the delete post or something like that, it'll just, it'll validate if you typed anything, but if you didn't type the method or anything like that, it'll just go ahead and fill it in, which is pretty slick. Cool. All right. Well, with that in place, we only have like a few minutes left. So let's bang out on the command line. Let's install this sucker. Okay. I assume we're going to curl bash something because it's 2018.
So I already have it locally, but I can show really quick how you have to install it. I'm going to, so easy with Homebrew. It's just brew update.
Perfect.
And install. And then let's check. What are you running over there?
I run Debian and Ubuntu variants generally.
Okay. So yeah, here we go.
There it is.
Curl bash.
Well, it's okay because after I'm sure. Well, okay, actually they've. This is not as bad as most curl bashes because all that curl bash is really doing is setting up an apt repository, and they give you the commands you need down here. And honestly, this way of installing things is very similar to how you would install even software like Spotify or Chrome, right? Like it's becoming pretty common that if you're an organization that wants people to install something on Linux and you're above a certain with it category, you just set up your own repository. Right. I will say that the use of keybase.io to distribute GPG keys is pretty on fleek. Okay.
It's quite nice. And then, yeah. So that's the installation for Crystal. For Lucky, I'm not sure if we should show that yet. Yeah.
No, let's just pop into the. Okay. Let's get a little hello world going. Let's make it crash a couple times. See if we can force some of those type assertion errors. Let's take it around the track, as they say.
Okay. Let me see. Using the compiler. So, boom, simple.
Yeah.
Just calling the command. So I installed it locally already. Let me see this. I have a directory here. I'm gonna just go remove everything in the directory.
And I'll get the docs open too, so we can pair program the sucker.
Okay. So
it's so funny that the tutorial on this thing is like add two numbers to each other, print hello world, web server.
Yeah.
It's like those are the things to do.
Oh. So let me see. If I just run hello world.
One of the things that's really cool about this Twitch stream is we managed to see a lot of different IBMers like development environments. We've seen a lot of Visual Studio Code. We've seen some Vim. I think this is the first time we've seen Atom, at least that I've been the host.
Yay. So we are in Atom, and I'm using, what is it, Facebook's, I think it's called Flux, which is quite nice, especially if you're doing JavaScript stuff. And of course, Atom also has the Crystal language, which I have installed.
Sick.
But you could just do Ruby as well, even though it adds some niceties to it. So anyway. So what do you think? Just the old Ruby puts hello world?
Yeah, let's puts hello world.
There we go.
Love them.
Crystal.
All right, can we run crystal -- help just for me? Yeah. All right, so it looks like crystal hello world.cr just basically does the like go run type thing where it'll build it and execute it at the same time. It looks like there's a build. It seems to have some form of init system, which is, I assume, like sets you up with a .crystal.yaml or something for all your dependencies, and he's assertive about whether or not your files go in /lib or /project or com.ibm.crystal.dev. And it looks like it. I'm sure it'll be retired soon, but there is a spec system, so there's kind of a way to like roll some Crystal native testing. So that it's like this is so great about living in the future, right? It's like when something comes out like this, it's got I'm not going to say everything's solved, but like some batteries are included.
Yeah, totally.
Yeah, this is tight. I mean, if we really want to we'll see how RSpec-y it is if we want to write some tests. All right, so we got hello world out there. Can you run ls-? Can I take control? Can I drive? How do I drive?
I don't know. How does this work?
Yeah. Oh, yeah. Look at that. Requesting remote control.
Oh, yeah. Here we go.
Oh, yeah. It's 2018. So if we do an ls-l, it didn't emit an artifact. So if I do a crystal build, is it then going to emit an artifact? Oh, maybe I need to.
I think you need to.
Okay, I see what you're saying.
Specify the file name, which is like hello.
Okay, so it's so funny. Like the tab key doesn't work. It like kind of knows what I want to do, but it doesn't really.
I'm also running fish, by the way.
Fish is a cool shell. This is the first time we've had fish on the stream either. If you're wondering what fish is, it's like different than bash or zeesh because it has among other things, kind of a cute looping system. Oh, now we've got some utilities. So this is our little executable.
There we go.
Pretty large, if we're being honest. But not that large, I guess. I mean, pretty large. Is that 800K?
I think so.
Anyways, doesn't matter. Not at the important part. Do you have any idea what the dwarf file is?
No idea.
Is that maybe the dependencies? Okay. I don't know what a dsim companion file is. All right, moving on. Let's do a simple loop. Let's go back to that person example, and I can type it if you'd like.
Yeah, try it. Do it.
Okay.
Do you want me to switch it back to Adam?
Yeah, I guess. Maybe you better type it. Let me look for the example we're gonna copy out of the docs.
Okay. So let me see. We could do just like an H or something like that.
Sure.
H. And then, I mean, there's a million different ways of doing this. Like that?
Yep. That looks approximately correct.
Let's see.
And you can just do the crystal hello world SCR. You don't need to mess around with the build system like I was like saying.
Yeah. Boom. 1, 2, 3, 4. Not very hard.
It's good stuff.
What if I add like A to it? Does it complain? Here we go. This is where the type system starts kicking in.
Okay, so what is this error really saying? Did you add an A to it? Oh, I see.
Yes, I added an A to it just to see what would happen, you know?
Because you don't have that automatic like dynamic programming, or not dynamic programming, but like in your dynamically compiled languages, like your Pythons and your Rubies and your JavaScripts or whatever, like it'll just, oh sure, these types just scratch.
Yeah, just shove them all together.
Yeah, sure. There's a really, we don't need to pick on PHP. Okay, so then is there type casting? Can we stir? Can we I to stir plus A, and that probably will succeed? Is that if we wanted this code to actually function?
Yeah, this should work. Boom.
Boom. Got him.
There it is. Yeah, so that's like simple stuff. What do you want to do now?
So I'll bang it out. What I want to do now. Oh, do I still have control? I don't know if maybe.
Yeah, you have control. Yeah.
Okay, so then we can literally type this example in from class person and stuff, but
one of the other cool things about this being a new language, its standard library is also a lot better than the standard library of a lot of old.
That is so true.
Ruby.
Like
it has a web server built in, that kind of stuff.
Yeah, like Python is the place where I'm pretty comfortable, and it seems like pretty much every language these days, there's a built-in HTTP client, and then no one uses it, and you just have to know that. And Lord help you if anyone ever needs to fix a bug in the one that everyone started using, because
Yeah.
All right. So now that we've got this little class defined, which might even be syntax valid. This is basically requiring us to initialize it with a name, and then we can also set an age. I guess we never put a setter on the age. Or how age? Oh, age just gets initialized, and there's only a getter. So we can come in here and we can actually Justin, you better type it because I don't remember how to instantiate it. But like if you instantiate it with a name called John, that'll work. And if we try to instantiate it with a 7, that'll fail, right?
Yes.
Okay.
Yeah. Should we try it out?
Let's try it.
Start with John.
Yeah.
And then, oh, wait a minute. Person equals person John, and then person dot name. We'll just puts it.
Perfect.
There we go. Save. There we go. John.
Hey.
Cool.
But if we try to get fancy at all with that typing, errors.
So, Mr. 17.
Boom.
No overload matches.
Yeah. And that's
Nice.
what you were talking about in terms of overloading.
Yeah.
Exactly.
Yeah, so it wants you to kind of use or build it in that way, basically, if you have multiple types. Although I think you can actually do this, if I'm not mistaken. What was it? Int 32.
Oh,
and then it would accept it, I think. Yeah.
nice.
So that's the other alternative. I think. Let me see. A lot of the things that if you have like getters and setters, then by default it will be, because there's other ways of creating getters and setters instead of specifying them yourself. By default, they are then whatever you specified and nil, basically.
Mm-hmm. So how can we get the so here we're making an explicit type declaration with this colon, right? And the pipe. I think you said that there's like a way to, I might have understood. There's a way to like leave this with just name in parentheses and then type something else somewhere so that it infers the type.
Yeah. So we can do this, for example, def age equals, and then age, and then we'll do at age equals age, and then let me turn this back to John. I'll get rid of the nil just to clean things up a little bit. And then we'll do person dot age equals just 17, just to see if the syntax is still correct. And then here age.
What is the equals sign on line 23 doing? 22 doing?
So this basically this is your setter.
Oh,
so this allows you to do this basically.
Got it.
So this is just kind of reading it, and that's this allows you to basically do that. But you could also do it like that. But then you'd have to remove the equals.
Oh, so it's a little like the C++ like operator overloading stuff. All right, sweet.
Yeah.
It's defining the operation of this operator. Cool. That's sick. All right, should we run it?
Yeah, let's do it. So let's see, we have 17-year-old John. That works perfectly. And now we'll change it to be something else, string. Let me see, something funny. Sweet 16. And then, so now,
okay, and that's like a pretty useful error, right? Like, hey, this thing on this line needs to be that, not this. I tried. Mm-hmm. It doesn't dump. I guess it does dump. I don't know. You need more complicated code to sample because like the other problem is like, hey, there's type error somewhere. I'm not going to be clear about that, but it looks like it's at least trying.
Yeah, and we never specified the let me see, the input type explicitly, right? It infers it from where you used it somewhere else in the class, which is kind of nice because otherwise you're like, there's so much configuration that you have to do just to be able to work with it.
Sick. All right, then let's do you want to show anything else on the language?
Let me see. We did the. Should we do the overloading?
Yeah, let's do the overloading really fast, and then let's like do like install a package, and then let's hop into Lucky real fast. Maybe Lucky will be the package we install.
Yeah,
okay,
makes sense. Okay, so let's do the age. Let me see. So if I specify nil here, age is nil. It's gonna complain. Okay, so it has to be int 32, not nil class. Cool. Now, if we do this, age equals age nil, we should be able to set. Oh, let me see what's going to happen then. Just age equals nil, and this is going to complain. No, it just works.
Nice.
So we didn't even have to say, okay, this has to be 0 or 1, just by specifying that there is an input that can take that, and then it can change. It already configures it in such a way that that it supports it, basically. I don't know.
Nice.
Rambling a little bit, but I hope you get the idea. Cool. Should we do Lucky?
Well, let's do. I want to install a shard.
Okay. Yeah, sure.
And then
have you looked any shards up?
I haven't looked at it yet. In fact, well, I'm almost there.
Okay.
So if you open up shard.yaml, I don't know if we got a shard.yaml for free. If not, we could probably use that like crystal build or crystal init or something in a directory to make ourselves one.
So how do we do that?
Okay, that's fine. I can. Am I still in control? Can we go back to the terminal?
Yeah, you're in control. Go for it.
I'm in.
Yeah.
Well, I think yeah. All right. Sweet. So if we make dir foo and we cd foo and then we crystal init at foo. All right, sweet. So we got all this stuff for free, right? It makes us a Git repository too, which is pretty slick.
Nice.
Yeah. And then
2018.
Yeah, it's the future. It even read some things from your like your Git config or something, I guess.
That's
right.
Cool.
And so this shard.yaml is obviously inherited from like a package.json type file for our Node friends out there. And the way you install a dependency is this. You just kind of come in here under the targets and you put a dependencies hash. And just like Go, this is all based on GitHub or Git anyways. And they, with all the required, Git variables, like, I'm sure that there's basically a million pull requests to add every conceivable need for Git. This one installs submodules, and this one use this other fork of this branch, but then revert this one.
Oh, you have a typo.
Oh no,
it's branch. Branch is brach.
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 Brach. I'm from Philly. I'm in Brach.
No, it's still wrong.
Oh,
it's not Brank or something.
See, this is why you can't actually like type on stream because you're not capable of it as a human. All right, is that better?
Yeah, that's perfect.
Did I spell dependencies right? Because that's the one I was worried about.
Dependencies looks right, but I'm dyslexic, so I don't know. Could be anything.
It could be anything. All right, and so then is it like crystal install? Whoops. I turned on caps lock, my bad.
No. I think it's something like Maybe it's like shard install or something.
Do we have a shard utility?
Yeah. I thought so.
Maybe if we did do a shard build.
It's a plural.
Oh.
Look at that.
All right, sweet. All right, so that worked. Okay, so let's do Lucky. Let's do Lucky.
Cool. So I'll go back to the Lucky website real quick. So get started.
Yeah,
so this one
is pretty intense requirements, if we're being honest.
Yeah.
Like, oh, did you want to write in Crystal? Well, let's get your node updated. It's fine. It's fine. Did you do all these things?
I did do all these things. Yeah. I was a little bit like, what's going on here? But yeah, I guess they want to lean as much as possible on top of if you're doing a lot of JavaScript because it's a web thing anyway, bring that in.
Yeah.
I don't know.
Hi, Sarah. Nice to see you again. Sarah's talking in the chat.
Yeah, no, it's cool. So I ran all these things. I installed Homebrew because I'm on a Mac. Installed Brew SSL. Brought in the Lucky framework. Installed it.
That's where it is, Sam. So you can let me know. I think that's reasonable to try to. Sam was asking if there's like a blank shard install -- save something. Like the npm -- save, but I don't know. I just linked it to GitHub.
Okay.
Anyways, we got 5 minutes. Let's get going.
Okay, cool. So you have to run just basically Lucky, and then init.
Yep.
And then should we do a blog? Blog's the classic example.
Well, we should get out of this directory because we're already in like the foo project.
Oh, that's true. Crap.
Although actually, it looks like it almost figured it out. I don't know what it's done at this point, but let's just make a new directory for it.
Yes, I'll remove my blog real quick, just to be clean. Here we go, in Crystal.
Yeah.
So it creates a new directory by itself. So we'll cd into it, my blog, bin/setup. And then we can run Lucky Dev after that. Yeah. Install node dependencies.
Okay. Well, I don't know what I expected. Do we know why this thing has a dependency on the node chain? Is there just useful stuff in the node ecosystem that it's just piggybacking on?
I think it's because it has. Let's look at the website again. I think why Lucky? No, this homepage. No, go back here. So I think because it has like native support for React and all kinds of other things, it brings in the whole node toolchain so that it can just leverage all of the basically things that support that already. So I think that's why there's some gulp stuff going on here, all kinds of different things.
Yeah,
and clearly it's taking a little while.
I mean that's like standard.
Yeah,
it's pretty standard. It looks like there's an issue where here's a real issue title from the Lucky framework called consider moving from Yarn back to npm. So it seems that the discussion of which package manager in the JavaScript ecosystem is no one is safe.
It's funny, isn't it?
Yeah.
And well, I guess that's a nice thing about Lucky is they already have one built in. There's no.
Well, and the other thing is that like most of the times I'm writing an app of any significant size, I end up with something like a Webpack or something in there where it's like, okay, well there is a JavaScript component of this app, and that requires some tooling and some integration. So basically, Lucky saying like I'm opinionated, here's the plan is not the worst thing I've ever seen. And
Yeah,
it seems to be like that green output with all those lucky blank dot gets is almost certainly going to be the shards utility.
Mm.
Yeah, we should look at the shards.yaml or the shard.yaml once we're done and see like what entry points it's selected for us. The other thing that's kind of visible from just looking at this website is they're like clearly saying like, well, there's kind of a process manager component to this thing. Like, what do you want to be the thing that actually starts the app? That kind of stuff. Oh, yeah, that's pretty cool.
Yeah, so this is all the dependencies, or the shard. This is a shard.yaml.
Yeah.
So you can see the lucky, and it's going straight to the GitHub.
What's in package.json? Is that where they define like a start stop status? Yeah. So basically, they're using the built-in stuff that's kind of like, this npm scripts object has been popular of late, where it's just npm start, and all apps respond to npm start, and that's what we mean. As well as having a watch, which allows you to just quickly have the app restarting while you're demoing on it. So it's all good stuff. And again, that's like just don't reinvent the wheel type stuff.
That makes sense, Why do that? Although that seemed like when I was doing PHP, that was the most fun of it. It's like, okay, we're working on a new project. Start building a new framework. Don't use any packages out there. I'm lucky. I'm happy that the ecosystem has changed a lot since I got into that. But that was kind of, I don't know, maybe most of the fun of it or something. Setting up the database. Let me see.
Yeah. Sarah, I would definitely not recommend diving into Crystal as your first job, as your first language to learn. But it's always cool to have some finger in an experimental language like a Crystal or something.
Yeah, totally.
I was gonna say and Rust, but Rust is actually getting more mainstream. So
we have to move to something else. You have to. If you're a hipster like we are, you have to move to something experimental.
I live in the Midwest. Justin is the one in Brooklyn with the beard, okay? I speak for the people.
Okay, fair. Then I'll keep it to myself then.
Yeah, it's fine. It's fine. We enjoy your coffee out there. It's good stuff. Okay, so this installed a database for some reason. That's cool. I'm glad it asked. I have some questions. Is that probably like an SQLite? Is that what we're thinking?
Let me see. Well, let's check out the config. And then let me see, database. So this is just the... No.
Maybe env.cr up there?
Env? No.
Oh. Yeah, that's the app, managing its own configuration. So
maybe where was it? Oh, here. DB. No, these are the migrations, which are also useful. Wait, I had the web page up here somewhere.
Yeah.
Okay, so here's the host name and the database name.
Mm-hmm.
And that where does that come?
Okay, so we have a thing called Lucky Record instead of Active Record.
Yeah, it looks like that.
Yeah.
Yeah. Okay.
ORM for you want to take a whack at explaining what an ORM is? Because I'll probably screw it up.
Okay, let me see. So an ORM basically creates so you have, and let me see, how am I going to start this? Okay, an ORM, officially called an object
relational
mapper. Yeah, basically maps objects that you have in your Ruby or in your Python or in this case in Crystal. It maps it to probably a database table 9 out of 10 times. And then instead of you having to go ahead and typing SQL or something else to get these get the records in, you basically just type something that's native in the language, and it will go ahead and talk to the database and get the records that you want. You can even, in this case, you can even edit. So say you have a people table in your database. You pull in a person, and then you have a person object. You can change the person name. You call save on it, and then it does all of the queries to the database to make sure that those are all nicely in line. And then the nice thing about object relational mapper is, say your buddy tells you that MySQL is so 2003 and that actually Postgres is getting hip again. You can really easily just use the same syntax that you're used to, and just change the database that's running behind the scenes. And so that's one of the nice things about ORMs.
Yeah, so there's a lot of reasons.
What do you think?
That's great. Okay. That's great. We're also super out of time. Do you want to go over there and run? Just do like lucky run, and either it'll work or it won't. But we got to hand the mic over to whoever's next, which I want to say is John.
Oh, I didn't say Lucky Dev. That was it. Lucky Dev. Cool.
Oh, we're gonna give it to Anton as soon as we're done here. Yeah.
So it's running yarn in the background.
Is it going to give us a... Oh my gosh. It's like created a tmux for us because it's using Overmind.
Yeah.
This is this is like the edge of the hipster stuff. This is great. That's a hilarious little well, next stream we'll talk about what Little Snitch is and what it does. And here we go. This is our app. Do you want to go up there and highlight the URL just so people can believe it?
Let me see. Localhost 3001.
There
what
it
is it say in our terminal? Localhost 3001. And there's even a UI for it. What's this?
What's that?
Oh, it's browser sync. We have browser sync built in because browser sync is really useful. And why would you not want that built in? It's pretty cool.
Batteries included. I mean, anything that launches a tmux with like a bunch of different windows, that's like, okay. All right. So this has been Crystal and Lucky with Justin and Spencer. We are way over time. Stick around the Twitch show. We got a bunch more cool stuff coming for you on Friday. I am done for the day. Callforcode.org. Be sure to sign up, register, get access to some of the world's experts on things that aren't just science projects. And we'll be back in a couple short minutes with Anton, who's going to talk about kind of health and fitness and the blockchain.
Hi, I'm Anton McConville. I'm in Ottawa in Canada, and I'm sharing a talk with you today on real-world blockchain. It's the first time that I've given this talk. It's some material that I'm putting together for a conference in October. So it's kind of a little bit rough and ready, but concepts are all in there. I'm going to be hopping around, looking at some examples, and sort of sharing the process, some of the process that I've been going through. Just a little bit of my background. I'm one of those people who sometimes doesn't really know where I fit. I've spent half of my career working in design, half in development. I'm constantly researching, especially in my role as a manager, creating cloud patterns and examples for IBM's content and sharing with our customers and developers around the world. I've been sort of long in the clouds, working on Google Cloud before IBM's. I've been developing mobile apps for about 10 years, and my degree is in systems engineering, which probably explains why I sort of hop around and take a wider view of things. The little symbols at the bottom of the page indicate all of the places that I've lived for quite a long time, and sort of I put them there to explain my accent. I grew up in Belfast, studied in Manchester, and now I live in Ottawa in Canada, so there are a few influences in there. And for the past sort of few years, I've been building example apps and case studies. I'm using cognitive technology and cloud technology, so anything ranging from visual recognition through natural language analysis, mining Twitter and social media, working with IoT. And today, of course, we're talking about a sort of blockchain concept that we've been working on. So while the topic is called real world blockchain, it's not a commercial application, but it's certainly being used, and certainly something that we've gone through, I think, a genuine process that many of our customers at IBM would go through, or many people who are new to blockchain would go through. It's basically a wellness app. It uses your footstep data and converts your footsteps and puts them into our own homemade cryptocurrency on a blockchain. I'm going to explain more about the app later on. Generally, the agenda for this talk is a sort of refresher on how blockchain works, just a general overview of that. Then I'll talk about our sort of concept and give a little bit of a demo, talk about some of the architecture behind it. I'm going to talk about some of the next steps in our project and what we're doing next and how that's sort of helping us think even more deeply about blockchain, and certainly in the context of things like machine learning. I think they go hand in hand. And then because there's a sort of theme of the call for code around this, I thought I'd talk a little bit about disaster response and think out loud a little bit about the place for blockchain in areas of disaster response. So first up, I'll talk a little bit about how blockchain works, and I'm going to steal a fantastic example from an MIT professor. You can find this as well as blockchain.mit.edu. Totally recommend playing with it. There's a really great little video where he explains it all to begin with. But I'll walk through some of the sort of basic concepts to start off with, and I think there's a subsequent session where we're actually hacking in some blockchain stuff, or maybe it was prior to my talk. So hash is really like a sort of digital fingerprint around some data. So if I write something that's a string, a data string saying hello world, and you can see that there's a hash code generated for it beneath there. So really what we're doing is we're running an algorithm over whatever data is appearing in here and making a distinctive code that represents that data. So it's really something unique that's identifying that piece of data. So you can see as I type, it's changing and adding in there. And that's the first sort of foundational building block within a blockchain. So if we sort of go one step further, and we've got our hash code in here, and this is the first sort of conceptual block in here. So we have a block number, we have a nonce, which is a sort of unique identifier that goes along with this block. Then we have our data in here again. So if I type hello world, as I'm typing, you can see that the block has turned red from green, and that's indicating that something's wrong with the hash because I've changed the data in here. So this time the hash is being calculated across all of these things, the block, the nonce, and the data. And what I can do is if I delete the hello world, you can see there's 4 zeros at the beginning of this hash code here. And that's what's signing it. That's the actual signature mark on this to indicate that it's healthy. So when I start to change it here, you can see it's getting unhealthy again. If I mine, what's going to happen is I can start to try and find numbers where this would get healthy again, right? So 1, 2, 3, you can see it's changing. Eventually, I'll hit a nonce where the whole thing will be healthy again. But if I mine, it's coming up with a number that's going to give me 4 zeros at the beginning, which is showing that this block is signed. So it's extending the idea of the basic hash and bringing it into a block with a bit more context around it. So a blockchain then is a collection of those blocks. So we have block 1, block 2, block 3, block 4, and so on. And the interesting thing here is I can start to change data, and it affects the other blocks. So it's a little bit like a linked list. You've got an indication of what the previous block is here. So the previous block you can see here is referring to the hash code on the previous block here. So if I was to go in here and say, hello, change the data inside this block again, you can see that all the blocks following that have now been affected. They've all changed because there's a dependency on the previous block. So if any of the hash codes change, it's indicating that there's something's being changed, and that's part of the strength of the blockchain. The more blocks that are in there, the more noticeable it is that something's being changed and has broken its hash code. It's broken its calculation to show the integrity of that data. So I can mine again here, and this time you'll see that it's fixed this one block, but still the others are red because they're all depending on the one before it. So I've mined the one at the end, and you can see that it's fixed based on this block, but they're still out of whack. So this is, I guess, part of the strength of building on the integrity of each block in the chain. And on top of that, we distribute them. So this is part of the strength again. The idea is in the open public, for people who are members of this network, this blockchain network, they can make their own copy of the network. And, so if someone was to go and corrupt some of the data in here, these are identical copies. You can see, the hash code here, 0000012FA is the same as block number 2 up here, 00012FA. So if I change the copy in peer B, you can see it's breaking all of these other blocks, but it isn't affecting these ones. So peer A and peer C are still the same. A quick check on those hash codes in here will show you that 2 of them are the same, 1 of them is different. So this, obviously something's gone wrong with this copy. So as well as being security in the blocks being linked, there is now security in the duplications of it in there. So you keep building and building the strength of the data. So if anyone goes in and hacks or changes the data somewhere along the line, it ripples up eventually, and you notice it. And then further to that, we can put transactions inside there as data. So this is where, you know, the real value of it comes in as a sort of ledger, where you can sort of catalog different transactions that go along as part of that data. And even any single one of those transactions can cause a change in the hash code eventually. And I'll cut short my theft of this example here and urge you to look at the video for a really wonderful explanation of it all. But I thought I'd give that sort of little bit of context to begin with. Oh, excuse me, it's going to go through all of these screens again. So there are some of the blockchain characteristics that that people keep talking about. And there's a lot of hype around blockchain, as I'm sure everyone's sort of noticing. But these are some of the traits that are publicly accessible by anyone in the network. Additions to it are permanent. So obviously, if you go back in time and change one of the additions, someone's going to notice somewhere. There's no centralized authority. That you've got a decentralized thing with copies of it around, and everyone's copy is a further strengthening of the integrity of the data within the actual chain. And you can store details about several different kinds of assets that can be modeled, and data can be modeled in lots of different ways. So in I started learning about blockchain, I think roughly a year and a half ago, and I became a little bit really fascinated by how people are using it. So I started subscribing to a Google alert every day, and it sends me information where people are using it. And somewhere along the line, I came across this little map where someone's keeping an up-to-date sort of list of different public projects that the corporations and organizations are building on. And so, for example, there's an accounting, I think it's here, maybe the accounting one, or maybe that's not the one. I'll just pick something random. So here's the Russian banks one. You can see that there's a bunch of different members working on it. There's lots of insurance companies collaborating on different insurance blockchains. And one of the things that's sort of interesting is where there's a shared interest in the underlying data, but there's a tension in not wanting to directly collaborate, for example, with the other banks on some of the details of that data, but wanting to share certain aspects of it. That's where blockchains can come into their own, where you can, reliably share certain aspects of the information between a network of often competing organizations, competing but collaborating. So, as an example, two insurance companies might need to collaborate in the case where someone has a car accident with another car. And there are certain aspects of those insurance policies that they want to share with each other, but not all the details. So things like a blockchain can help facilitate that and be very trustworthy in sharing that information. So this was a little map that I came across, and I can post the link if anyone's interested after. I just wanted to show you that it's really active, that the world is really actively looking at this stuff. Governments, insurance companies, banks, healthcare companies, they're all sort of looking at how they can use it. The example I'm going to show you, we have built using Hyperledger. It's a project, an open source project that IBM backs and helps contribute to. I'm not going to go into all of the nuts and bolts of how to get started with Hyperledger. That's a long talk. And I'm hopeful that maybe one of the subsequent sessions will go into some of that hacking. There's some great tools around it. There's an increasing amount of really wonderful introduction material about it. I'm also going to post some links to some of the code patterns on the IBM developer site. which will show you how we used it with Kubernetes, Hyperledger running on Kubernetes, and how to get that going. But this is the overall project, and it's a really good, the hyperledger.org is a really good place to start to dig into some of that stuff. And then one of the things that got me sort of really interested was this book called Blockchain Revolution, and reviews of it have been mixed. I think if you're looking for a book that's really going into the technical nuts and bolts, this possibly isn't the book for you. But if you want to go into more of the social impact, the potential social impact of blockchains, this book's really fascinating. And it certainly got me thinking quite a bit about how the world could change, or how different services could change with blockchains on there, principally around areas of self-organization, for example, or social networks that are not sort of controlled by someone making a lot of money off advertising. There's lots of potential for using blockchains in a sort of social way, but still having, rock-tight data on there that you can rely on. In the first sort of few opening paragraphs of the book, they explain that blockchain is really a peer-to-peer exchange of value. And for me, that's sort of a huge shift, thinking not of data just as information, but thinking of it as well as value. What's the value around that? And, these days, this year, in fact, we've seen, Facebook being used, or a lot of news about Facebook being used for political interference based on selling of data within that network. And you think about how you're actually building data with your activities on a social network all the time. And so there's an inherent value of that data, which, these big companies are using for advertising revenue at the moment. We are getting something in exchange for it. We're getting the use of a social network or map technology, that sort of thing. Google Docs tools, that sort of thing. We get open tools that we can use, and they're wonderful tools. But we are also sharing a lot about ourselves, and that sort of locking onto that value of the information that we're giving over. It's a really interesting way to think about what's the value of that, and how is that going to change in the future, especially as we move into different models where we're going to have autonomous driving and things like that. So getting back to our little concept, this wellness and blockchain app. So the sort of inspiration for that comes from an app in Canada. I live in Canada. We have this app, or this tool called Carrot Rewards, and it's actually being developed or funded in partnership with the federal government and lots of the provincial governments in Canada. It's a really neat idea. And what they're doing with it is they use it for a couple of things, to teach you about, being well, being healthy. So they have like little games that you can play where they'll sort of teach you about the importance of different nutrition. But you can also sign up, and as you're walking around, it will convert your footsteps into Aeroplan miles or Petro-Canada points. Something that you can exchange for like a flight, or something that you can exchange at the gas station. And so the governments have funded this as a way of marketing to you, how to be healthier. Obviously the governments want to keep you healthier, especially here in Canada, where healthcare is paid by the taxpayer. So, it pays for the government to keep us healthy and not, benefiting that much. Like, we don't want to, I suppose, in any case, but there's logic behind it. And there's the same logic with private healthcare companies. They are increasingly teaching you how to be healthier. Lots of employers are also doing this sort of thing. Even at IBM, they have schemes where they'll reward you either through some direct benefit, if you are seem to be exercising on a regular basis, or they'll give you like a Fitbit to encourage you to do that. So there's a whole sort of realm of wellness going on at the moment. And the thing that inspired me about this app was when I signed up for this app, it knows quite a lot of information about me. It knows about my height. I think it has access to the health kit on my iPhone. So it knows my gender, it knows my age, it knows my address, and now it knows how frequently I'm walking. So that's all data that it's getting. I've volunteered to give it that data. I, rightly or wrongly, I trust the Ontario government. I trust the federal government. But you could be forgiven for not trusting your government these days, I guess. And it certainly begs the question, what's a safe way for doing this? What information do you want to share with your insurance company? What information do you want to share with your government or your employer, but still be able to benefit from like health and wellness? And that's where the inspiration and the question came from for us, and the starting point for us building our own wellness app that kind of tries to do things differently. So again, think about this as a peer-to-peer exchange of value. In this case, we're exchanging our wellness information or our footsteps in exchange for something else. And what we decided to do was make our own cryptocurrency called KubeCoins. We're running Hyperledger on Kubernetes, hence the KubeCoin. We wanted to take it to the KubeCon conference in Denmark, and we did that. And the idea was we would take it there and we would invite attendees at the conference to load the app, to walk around and to spend their KubeCoins on swag that we would offer. So we offered, t-shirts and stickers and different valued things. And for every 100 footsteps that they walked, they could earn a KubeCoin and come back and buy swag from us. And even our little inventory, our store for exchanging all of that stuff, it was inventory controlled using blockchain. All of the footsteps, every time you open your app and update the network about how far you've been walking, those are all transactions on a blockchain and stored on there. So you could buy swag with them. We had a leaderboard so that as people are walking around, the person who's walked the most would get a prize. It's all anonymous, so we didn't ask for any information about the people participating. All we did was we stored a blockchain ID on their phone, and so for all of the transactions that they made, they would call back into the blockchain using that ID. In theory, the data should be encrypted. You can see to the left of this view, this is our dashboard that we put up on a screen at the event. You can see that there are blocks on there. So there's block 1548, very similar to the example that I showed you before. You can see that there's a hash at the bottom of the block, and then inside it you can see the data in there, where there's a Bitcoin balance and the total number of steps in there, and so on. That data that we're carrying in there would be encrypted. Ordinarily, we decrypted it just for the sake of being able to help show in real time what's going on at the event. But we tried really hard to retain, an anonymous presence on there. We built a little app to generate random minifigure pictures to go along with it, and random names for people, so that they could just identify themselves on the leaderboard. And we started putting some push notifications, so we could blanket push notify, to say that Gustavo Lambert, for example, was the winner, and could he come and collect his prize, or he or she. So this was a concept that we were making to put our technology actually in the hands of people, to sort of see how fast it worked, to try and trigger some thinking about this whole topic of blockchain. I'll quickly show you the app in operation here. So it's this KubeCoin app. This is my phone. We took it to DockerCon as well. So we have an iOS app, we have an Android app. The first thing that you see is a little booklet where we're sort of sharing all of the sort of code resources and assets. It's all open source. So we've written some Git repo guides on how it's put together, how you can build similar things yourself. And we built it sort of around the 5 tenets of cloud approaches to building things. So cloud native, accelerated DevOps, secure stack, modernizing, managing microservices. There's a lot of microservices in here. So we're trying to explain, use the app to sort of explain some of our technology. The main sort of view of it is this little footstep view. You can see the randomly generated name and picture. We're not currently running a live event at the moment, so I'm in position 0, 0. But my phone's recording my footsteps in any case. It's using HealthKit, which is a really cool library on iOS, and the equivalent on Android to record your footsteps, and then it's directly putting those things onto the blockchain network without interference. So we're minimizing the interruption between the human, like the recording of the human footsteps, and the transaction that goes on to the blockchain to retain the integrity of it. It's estimating how far I've walked, and then if I was actually in an event, it would be allocating me KUBE coins and telling me how many I've earned during the event. Here in this view, it's probably not going to work either because, again, we're not running a live event, but it would show the list of items that you could buy and the costs associated with those items. One thing that we struggled with, because I mean it's quite a sort of agile app. It's built using a team of 5 people as a part-time thing over 6 weeks at the beginning of the year. So we didn't do it full time. We, a day or 2 a week, depending on who was working on what. So we built it quite quickly. So it's rough and ready. And so one thing that we learned was the value of things. So say we had a T-shirt on there, we would say, okay, a T-shirt is going to cost you, 100 fit coins. So that's 10,000 steps. And we were thinking it would take people maybe a long time to do that. What we were finding was that they were walking the steps pretty quickly, and we were running out of inventory pretty quickly. So we started manually adjusting the price of the merchandise based on what we were seeing of people walking. And so that's sort of inspired some of the next steps in machine learning. I'm going to talk a little bit more about that later. And then we have the leaderboard on here as well. So that's sort of the structure of the iOS app. The iOS app, again, is all open source, and you can connect with me afterwards for references to those repos. That's sort of a demo of the app and the dashboard and what we put together. I mentioned the 5 tenets of cloud development there, and we have lots of code patterns related to all of this stuff, all of the work that we've done with this. This is a sort of high-level architecture of how things are being put together. So it's running on Hyperledger on Kubernetes in the IBM Cloud Container Service. We have a node server on Kubernetes that handles some of the stuff with the leaderboard. So we're doing some rough calculations on using the blockchain on positions and then putting that into a MongoDB. We're sharing some of that information just really quickly using a node app running on Cloud Foundry. It's just a really simple thing. Just using some RESTful interfaces on the Mongo database. And it's Mongo on Compose. It's probably my favorite service in IBM's cloud. It's so fast and efficient. I really love how it works. We're using cloud functions as well in the generation of some of the the random minifigure pictures and things like that. And even the booklet content, what we're doing is we're sourcing that from the GitHub repo, and we have some cloud functions watching the repo. So every time the repo changes, it's generating new structures for the little booklets within the app. So once you put your app onto the iTunes store, you can't change the app, but you can change the data. And so we tried to come up with like a very DevOps way of doing that to make sure that you could we could sort of fall back on the last well-known version of the booklet if we messed up somehow. So we're using GitHub as a content management system and Cloud Functions as a way of recognizing that the content has changed. At the bottom of the picture is the developer sort of doing the local testing using Docker to run some of this stuff locally. We stress tested it within our labs and got a whole bunch of people using the deployment before we went to KubeCon. And then the developers, deploying the mobile apps to the relevant stores that work alongside this. This is a sort of deeper dive. I'm not going to go too deeply into it for the sake of time. There's a lot of material written about this stuff as well, but it just gives you an overview of some of the action that's going on in here. We're cutting across the board of lots of technologies. As I mentioned, Cloud Functions, Kubernetes. We're using Cloud Foundry as well. We're using RabbitMQ, Redis, Compose. And I think that this is maybe a symptom of the fact that we're like kids in a candy store, that we have access to all of this stuff. You could argue that, but on the other hand, these just feel the right sort of application of technology for the right problem that we're trying to solve in doing this stuff. And the neat thing is that it all works sort of really well together. It's a very modern cloud-based application that we're drawing on the necessary pieces of technology, the right thing at the right time, building it with a very small team very quickly and getting it out and learning from it. And that's the approach that I hope that we see other people experimenting with blockchain. So sort of what's coming next, if you look at, so what happened was we ran this a couple of times really as an experiment for ourselves to see how much we could learn about blockchain, how we would build it on our network, how we would share that information with the wider world. But word got out within IBM that we had this little application, this concept. And so a bunch of other people requested if they could use it at events. And so we have these upcoming events now where other people are going to be running the app. And we weren't necessarily set up for doing that. We have one blockchain fabric for the two events that we've run it at, KubeCon and DockerCon. All we've done is cleaned out the existing fabric and restarted it. But that doesn't scale easily for other people. I mean, we're able to do it because we're very familiar with it. The other thing that happened was we had some of IBM's clients take a real interest in it. Some like pretty cool ones. I obviously can't talk about them, but in areas of fitness, in areas of insurance, and then actually in areas of government, we had interest from a few different people who had seen or heard of it at the events that we were at and thought, you know what, we've thought about some of this stuff as well. So it was kind of cool seeing that. But for our own sort of little homemade application, it gave us a problem in how do we share this and how can we scale it so that other people can easily use it. We don't necessarily want everyone to start up their own blockchain. We are very open to replications of it, of course. But how we thought we'd start would be to see how Hyperledger could help us, have different channels within it that could support different events. And that's what this has forced us to do. And I'm sort of happy that it's done that because it's making sense of those questions. How do we start scaling it? We don't necessarily want, the Java Zone event, knowing about the Stockholm event, for instance. So this is sort of exciting for me. And one part of the reason I put this slide up here was to show where other people can see this in action if they're attending any of these events. But the second part was to sort of explain the problem that we made for ourselves in our little side project getting out of hand. I'll be talking about this myself in Italy in September. This talk is the first sort of iteration for what I'll be talking about there, and then the other events will actually be running the application, or someone will be running the application. For the Cloud Foundry Summit in October, we're going to add in some machine learning, and that's some of the evolution that we're making for this app on the side. So rather than call it KubeCoin, we're now calling it Cloud Coins, so that we're not focusing on one sort of single cloud technology. And the first sort of view of the app, this is the design for that. We'll have this little link on there to say you can join other Cloud Coin events. We're still mulling over how best to position this, but we're breaking the blockchain fabric, the Hyperledger fabric right now to be able to support multiple events. I'm using Hyperledger channels. And so you'll be able to pick whatever event is relevant. We can also put some geolocation around that to make it default to the event that you're closest to, and some time management around that to sort of not show the events that have elapsed going forward. We do want to sort of have a notion of an understanding of how other events have used this, like how far people have walked in other events, and to show sort of you don't necessarily need to be intrusive about the personal data of people to still learn from using apps like this. We can keep people anonymous and still learn what's going on. We can learn, what the interest or uptake is. We can learn things like the split between Android and iOS. We can learn how far people are walking in the different events. There's lots of information that you can still learn while not being intrusive, and also giving someone, a participant, the power to decide how they use the value they're creating in using the app. So I mentioned about machine learning. Obviously, machine learning is good for predicting. So we're going to use the data that we've already sort of gathered from our previous events to seed the predictions for the next one. And then while the event is going on in real time, we're going to predict, how many people are going to join the next day, how much is going to be walked the next day based on the most recent data. So the views for that, we'll add another view into the app, and they're going to look something like this, where you'll see a little chart of the initial prediction in orange here. You can see as an example, this is what it's predicting. The uptake of participants will be. And then the navy line is showing the actual participants, and then the pink line at the end is showing the new prediction based on how things are changing. So this is the initial design that we're going to show for that. It'll show the participants, the steps walked, and the distance covered. And again, this sort of echoes right back into the real world. If you have a store or you're selling something based on demand, this is where you would use this stuff in real time, this real-time predictive technology and machine learning ideas that can come along with that. So we're sort of geekily excited to play with this stuff and get that going, to see this in real time during the events, to see what numbers it actually shows up and what we can learn from it. This is just a sort of initial plan of how things are going to roll out across the team over the next sort of 10 weeks. As I was saying, I have a sort of background in design as well. I drew the iconography and the images for this app, and we started with a little palette that tried to be playful, like sort of reflect wellness, but also still try and be formal in some ways. And so we've been playing with those colors. We tried to make a fun footstep to go along with it. I use Adobe Illustrator for drawing, so you can see the things that I've been drawing. Some of these icons come from IBM's design icon library, which is also open source. I'm a big fan of it. It saves me time, and I think quite a lot of the icons are very simple and beautiful, so it's really easy to use them. I also use Sketch for coming up with some of the views for the iOS apps and for the mobile apps, and developing those. It's really easy to share those concepts as well and get feedback on them. So all of those things sort of work really closely together. Apple have actually provided plugins for Sketch with real sort of imagery of the components that you would build an iOS app with. So it's totally wonderful for working with all of these things when you're conceptualizing and designing. I mentioned our little minifig library. It's an NPM library that we published. We haven't sort of written about it yet. We're still sort of tinkering with it, but it's pretty simple to use in that it's Node. You just require a minifig, and then you can say, make me an SVG, and you can feed it a color palette too. So our color palette is obviously matching the app that I just showed you, but we've used it in another app as well, for another event, a different app, to try and keep this anonymous, presence in the application. So it's a pretty simple way of using it. It'll give you back an SVG image. And it's kind of like Frankenstein's monster. We've got a bunch of different Lego hairstyles, a bunch of different colors and skin colors and genders, and it'll just pick whatever random hairstyle and sweater color goes along with the next call. So we're building a little service around that to help us keep our participants anonymous in the future. So another little fun thing. So there's a few links. There's a blog post about how we use this thing or how we were using it at DockerCon. So quite a lot of the talk that I've given is very similar to what's in the blog post there. Hyperledger on Kubernetes. So it was a really good code pattern on IBM Developer that shows how we set this up. All the details are there on how to deploy Hyperledger on Kubernetes. Very often, there's a lot of discussion about where to start with Hyperledger or how much a company should invest in it. In my opinion, obviously I think it's important for companies to start looking at this stuff. The potential is enormous for doing things with this kind of technology in the future. This is a really inexpensive way of getting started with it. Run your own Kubernetes deployment of your own blockchain just to get started with it. If you get serious about it afterwards, then obviously there are more professional ways of hosting that blockchain network, but dipping your toe in is the way to go, and this is a fantastic pattern to get started with that stuff on your own terms. And then Anthony and my team put together a really great pattern on how he built the Android app for the concept that I just showed to you, and that's all the Android code is there as well. All of the iOS code is there as well. So we've got lots of really good material to show. It's all open source on how we build our apps. So we'll open up. You can see we've got these apps here. So that's the blockchain, the real world blockchain app that I was talking about. I think I've still got a few minutes. Since we were talking about Call for Code, this is a project I worked on with a nonprofit a few years ago. It's an organization called Shelterbox, and they respond to people who have been displaced by natural disasters. I built a mobile app for them. Their data was really, really inspiring to me. And really all the app does is sort of puts a timeline behind the deployments that they worked. And what they do is they bring these boxes with a tent in them and cooking equipment. The tent can sleep 15 people. So they'll fly out, dozens of boxes or hundreds of boxes, depending on the disaster event that happened. And, their cause is to help people have a roof over their heads when they've been displaced. So the data was a little bit, it wasn't well organized, but it was sort of all there in some form or another. So I cleaned the data up and built a timeline of deployments and itemized it to be around whether it was a fire or whether it was a conflict or a storm that had displaced people. What I found was that for most of the big disaster events, there's a Wikipedia entry. Lots of people are tweeting about that stuff, and it doesn't take much to string together a quick search and surface some of that information. For me, the most amazing thing was once you get a timeline together and start plotting all of the places that they're responding to or have responded to. It sort of paints a picture of like where the world is vulnerable and where, for different kinds of events, it's suffering, and there are places that are repeatedly hit by storms, for example. There are places that are repeatedly hit by mudslides or fires. And the data starts to tell a story of that. When I was building this, blockchain wasn't around, and the one sort of thought that sort of crossed my mind is in sending this information, sharing this information with other people. Because I remember when I was working on this, the organization often told me that they had to be very careful about where they delivered the boxes, because other people can get to the boxes first, or there are people who will take advantage of the fact that there's a set of hundreds of boxes or dozens of boxes with valuable things in them. So it's really important to be efficient with sharing that information, but to keep that information secure as possible. And also to keep a sort of network where other people, other organizations are deploying and getting different things, whether that be food or clothing or medical care. So a sort of blockchain network for disaster recovery would be an amazing thing to be able to help protect that information and help keep the organizations in sync with what's going on. And I think there's a huge amount of potential for working with blockchain in natural disasters and in charitable responses and things like that. So I think I've reached pretty much the allocated time. I guess I can take some questions. If there are any questions? Okay. Okay. Thanks very much, Michael.
Hey everybody, Oliver Rodriguez here. I've done a few of these live streams before, so I may look familiar, although my beard is a little longer from last time. So I'm back today to tell you about blockchain a little bit more. And more specifically, I want to get into some of the details around access control around your Hyperledger Composer applications. I've seen a few questions come in on the Slack channel. If you've been participating in that, a few of these questions have come in around certain permissions and how they work with your Hyperledger Composer applications. So I kind of want to go through some of that today and show you exactly how that would work in your application. And then I'm going to go through one of the newer code patterns that came out, and we'll show you exactly what those permissions will allow you to do. So really to start off, I'm going to go through just a quick presentation just to give you an idea of what this access control looks like and how you can incorporate it into your business network definition. So let's get started. So if you've been building your business network definitions, you may have seen this permissions.acl file. And what that allows you to do is really specify these permissions. And you can do that by restricting which resources can be read and modified by basically whoever is part of the network. And these permissions are defined in the permissions.acl file. So that's going to be a part of the business network definition, although it's not always required. It is optional, but I'll tell you why you want to require it later on. Also, these rules can be as simple or as complex as you want. On the left side, you can see a few examples of these rules. The very first rule there is really simple, basically saying everybody can allow anybody to read, anybody can have read access to all of these resources, basically. But the one below that in the middle is a little more complex. As you can see, there's some variable assignments, particularly on the participant and on the resource properties there. And then you also have a condition field, and I'll get to what that is later on. So that allows you to incorporate some logic into your rules to really control who has access to your objects. And lastly, this system ACL rule you see at the bottom, that's going to be required to actually make these changes and deploy the updates through the Composer playground and so on. So let's go ahead and talk about what ACL stands for. So ACL is used a few times through Hyperledger Fabric and Composer, and it can mean a few different things depending on the context in which you use it or which you see it. So ACL can stand for Access Control Language, and that's the language that we use to build these rules. So if I go back to the previous slide, you can see that the syntax of these rules and how they're written, that's the access control language. And you can see the file extension ACL on the file. Access control language is what it stands for. Secondly, access control logic. So in that condition field, you have that logic that specifies, which field has to match which field in order for that rule to apply. Well, that's going to be some of the access control logic that you write in access control language to specify these permissions. And also at a lower level, ACL also stands for access control lists, which are permission lists in the Hyperledger Fabric network layer, which allows certain participants certain access to network resources such as system chain code and so on. But that's a little too low level right now for this presentation, so we're going to stay with the Composer definitions of access control language and the access control logic as well. But lastly, if you're from Austin, Texas, you may know ACL as Austin City Limits, which is just a music festival here in Austin. It's funny, that always comes to mind first whenever I hear ACL. So, access control rules. So these are the rules that we define in our permissions.acl file. And so in these rules, you specify exactly what the rule is doing, who's doing it, and what operations are allowed, essentially. So there's a few different fields that are in these rules. The first one is description. That's pretty self-explanatory. It's just a description of the rule, essentially. Quick sentence here or there. It's just a code comment for whoever's reading it. You also have this participant field, which is who this field applies to, or this rule applies to. So on the right side, you can see this participant is the sample participant. So that rule applies only to that class. And you want to notice the structure of how that participant field is written as well. It starts with a namespace as well as the class definition, the class name. You can also make that as specific as you want. For example, you can point to specific class instances. For example, if you have participant Bob. You don't like Bob. You want to restrict his access. You can give him a rule just for Bob that says, no, you can't access the network. I don't like you. You can do things like that. But we like Bob, so we'll allow him access to our assets. So the next field is operation. And these are the simple CRUD operations: create, read, update, and delete. And or if you want to specify all operations are allowed or denied, then you can just write all in all uppercase, as you can see in the sample rule there on the right side. You can also create a comma delimited, can't say the word, but comma separated list of the operations you want to allow. Say, for example, you want them to be able to create, read, and update, but not delete. You can just write create, comma, update, comma, delete, and they'll have access to do those specific operations. The next property available is a resource, and this is what the rule is applying to, so the target of that rule. And so again, back to our sample rule, you can see that this sample participant has they can create, read, and update all instances of class sample asset. So essentially, they can do whatever they want with the sample assets. And so that again follows kind of the same syntax as the participant field, where it has a namespace and then the class name. And as well with the participant field, you can also specify that to be specific instances of the class, or you can just have all instances of the class, as you can see here in the sample asset. So you can really narrow that down however you'd like. The next field is, the next two fields here are for, oh no, I skipped action. So action is basically what the outcome is. Are you going to allow them access to this asset, or are you going to deny them access to the asset? And so it can only be one of those two values. It can either be allow or deny, and it's just, that's it. And these last two properties here, these are for more complex rules. And so you don't always need these, but if you want to really make specific rules for specific situations, that's when you bring these in. So the second to last rule here, condition, basically, this is just some logic, a simple JavaScript expression, an if statement that has to evaluate to true in order for this rule to trigger. So on the right side, you can see another little example there with a condition field. You can see a variable being used there, which we'll explain in the next slide. P.getIdentifier has to equal R.getIdentifier. And essentially, we're saying that the owner of this resource has to equal the owner of this participant. Basically, whoever's trying to do this transaction needs to have ownership of the asset they're trying to change. And in the demo application that I'm going to be showing you later on, you're going to see how that actually plays out and what that exactly means. Lastly, the transaction property. This is where you define the transaction that needs to have been submitted before that participant can modify the asset. So say, for example, the last live stream I was a part of, I talked about REST servers. And so through the Composer REST server, you can create assets by simply submitting a post request to the asset endpoints. However, that might not always be wanted. You may want to have a transaction used to create the asset. So what you can do is you can specify a rule saying that in order for this asset to be created by this participant, they need to go through the transaction route instead of going straight to the asset endpoint, if that makes sense. Maybe you have some additional logic in this transaction that's needed to populate fields in the asset when it's being created. Whatever it may be, you can specify that everything has to go through that transaction. So a little more clarification on the resources. As I mentioned, this is what the access control rule applies to. So as I mentioned, this can also be applied to everything in a namespace. As you can see on the first example, or the first bullet point there for namespaces, it's just a namespace with the asterisk. That means that all classes in that namespace, this rule applies to that. But also, if you have the two asterisks, that means it's recursive. So everything under the classes as well. On the third one, you can also specify the class in the namespace, which we covered earlier as well. And you can see that example being used on the bottom right example. You can see that rule applies to all resources of class type car. However, you can also apply resources to individual instances of classes. I used Bob in the previous example, but in this example here uses car with the ID number ABC123. So this rule is very specific to one person in that it says driver Fred can only has access to delete the car ABC123. So he's the only person that can delete that car according to this rule. So you can make these rules really specific or really general, depending on what your uses are. So conditional rules. So this goes along with kind of the complex rules that I mentioned earlier. And as I mentioned, these conditions they're Boolean JavaScript expressions. So basically just if statements that need to evaluate to true in order for this rule to trigger. And when you start creating these conditions, you're going to want to use some variable assignment to make them in order to reference these previous fields. So for example, on the sample on the right side, you can see for participant, we have this M in parentheses. So what we're doing there is we're assigning this participant object to the variable M so that we can reference it in the condition line. And we're doing the same thing for resource, but instead we're using V. And so essentially what's going on in that sample is we're looking at this sample asset, and that asset has a field of owner, and that owner is going to be a reference to an existing participant. And since it's a reference to that participant, it has an identifier, a unique identifier to that participant. And so what's happening is we're looking at the identifier of that the participant being referenced in the owner, and we're seeing if it matches with the person that submitted this request. So as you can see here, the participant, we're also trying to get the get identifier from the participant, which if it is the owner in the vehicle asset or the sample asset, they should match up, and then this rule should be applied. So that's kind of a more complex rule, and this is how you really start building these permissions that allow certain people to do certain things depending on these conditions. So just a quick note on the evaluation of rules. These rules are evaluated from top to bottom in the permissions.acl file. And it's it's not required, but it is recommended to have the most specific rules at the top and then the least specific rules on the bottom. That's because it makes scanning the decision table faster, as once it finds a rule that applies, it stops evaluating the rest of the rules. So yeah, the first match found is used and all the other rules are ignored. However, if there's no matches found, then it's an automatic deny. So it plays it safe and says, well, there's no rule specified for me to do this action, so I'm just going to deny it outright. However, if no permission.acl file is found, all access is permitted. So it gets kind of tricky there. So if you don't even include a permissions.acl file, everything is allowed. But if you include it and you don't include any rules, then everything is denied. So you want to make that clarification that you have the specific permissions, specific rules that you really need for your application, or just not include it and have just all access granted. So it's up to you on however you build your application. So now let's get into some of the code. Enough of this presentation. So let's go ahead and take a look at a sample application. All right. So I do have a second screen this time, which makes it a lot easier. So I can see your chat if you have any questions. So feel free to hit me up with any questions if you're curious. All right. So so to start off, the application that I'm using it's a modification of the the track donations with blockchain pattern. So I'm starting off with this one because this pattern has a few different participants with a lot of different transactions. And you really get to see how these different participants interact with each other and how the permissions come into play. So this is a really good pattern to start off with. So if you haven't done this pattern already, I recommend going to the IBM Code website, going to the blockchain technology page and finding this one, the track donations with blockchain. So it's a really great one to start off with, especially if you're talking about ACL rules. So what I've done is I've modified the permissions. Originally, the permissions were very loose. You could have access to do pretty much whatever you wanted. So I made them more strict, so you can see how these permissions play off when someone doesn't have access to do what they're supposed to. So what I've done is I've created a fork of this application. Let me just find it. And with that, With that, I changed these permissions, as I said, and it'll give you access to these stricter permissions. So if you go to my GitHub, or I can just paste this in the chat. Oh, I'm not logged in. Let me just log in real quick. But so you can just clone this. You can just clone this this repo if you'd like, or you can just. It wants me to do a CAPTCHA. I'm not going to do that. Oh nope. Okay, I'm in, and I can't paste links. So just find me on GitHub. Just Google OD Rodrig / Global Citizen ACL, and this is my my GitHub page that the GitHub repo that I created with the modified permissions. Actually, there are some changes that I just made before this presentation. So if you want to go through the code now and take a look at it, you can follow along as I do this demo. But I'll push some changes after this presentation, and you can follow along. So also, if you want reference to the access control language and you want to see exactly how the syntax is composed, the Hyperledger Composer documentation is a great place to start. You can find it on Hyperledger Composer docs. Just go to the page. There's a link to the docs right there. And on the left navigation pane, you can see the reference section at the bottom, which shows you exactly the syntax needed for all these different files. But it's a great place to start if you're starting with these files, you don't know what to do or how to create these rules. This is the place to go. All right, so let's go ahead and check out this modified Global Citizen application. So I'm going to go ahead and use the Composer Playground. Now, if you're not familiar, this Composer Playground is a web instance of Hyperledger Composer, which allows you to really play around with the business network definitions and just write them without having to download anything locally. So it's great for demos, great for just playing around with blockchain. You can get there by just going to composer-playground.mybluemix.net. You can just see it at the top of the address bar here if you want to follow along. So what I did there was I deployed a new business network by going to the BNA file from that repo that I pointed to. If the BNA file is not there, you can easily just Composer archive create your own BNA file. But I uploaded that, and what it's done is it's created a peer admin card for me, or a business network admin card for me to access this network. So I'm going to go ahead and connect, and then I'm in the network. All right, so let's take a look at the different files here. So if we go to the model file, what we have here, we have, scroll up, we have, I'm just going to focus on the participants right now. We have a government organization, we have an aid organization, and a global citizen organization here. And those are going to be the three main participants that we're going to be using in this demo. And then we also have this asset of Project Pledge. And so basically this application, what it's going to do is it allows an aid organization to request funding from a government organization. And it goes through a third party known as Global Citizen. And Global Citizen will really make sure that the government is they're keeping up with their commitments to these causes. And so you can see when the government has donated money, and you can see exactly where the donations are. So it's a really great use case, and it's, as I said, it's pretty detailed. So it's fantastic if you want to explore the different components of Composer. So those are the main components of the model file. We also have our transactions specified down here. We have create project pledge, send pledge to global citizen, send pledge to gov.org, update pledge, and then transfer funds. So the reason I chose this pattern is because different participants are going to be doing different transactions. And what I wanted to play around with was limiting what participants could do which transactions. So you're going to see how that's done here in this pattern. So if you're familiar with Composer, you're also going to know the script file. These are our transaction processor functions. This is really the meat of the application. This is what the logic used to modify the assets when you call these transactions. So it's all JavaScript. You can see our functions that we define, or that we define in the model file. you can see this is where the actual logic for those transactions are. So the next file is, of course, the permissions.acl file. So currently I have all these, I have all the rules here applied. So what I'm going to do is I'm just going to go ahead and delete all these for now. And we're going to see how that affects the overall pattern. So what I'm going to do is I'm going to copy all of these. And then I'm just going to paste that in here. Okay. So I'm going to go ahead and delete a few. All right. So let's see what rules we have in place. So to start it off, I wanted everybody in the network to see the actual project pledges. I mean, what's the point of having a verification network if no one can verify? So everybody's going to have access to view the project pledges. Also, I've given read access to everybody else's resources as well. So you can see the government's orgs resources. You can see the global citizens resources. It's very open and transparent, essentially. Also, I have rules defined for the specific transactions. So, for example, we see this aid create pledge rule here. And this basically says that the aid orgs, they are allowed to create project pledge transactions. And so we have one for each of the transactions for this aid org. And then at the bottom, we have the system ACL. So that's basically any of the participants can modify this system. And with the network admin, that's the current scope we're in right now. At the top right, you can see we're in the admin identity. And so these last two rules apply to this network admin. And basically, it's saying that we can modify the code here in Composer. So those are very important to have when you're writing this code. All right. So with that being that, let's go ahead and test it out and see exactly what happens. So the neat thing about the Composer Playground, if you've not used it before, you have this test tab. And this test tab is fantastic for actually testing out your logic, making sure everything works the way it's supposed to. And so what we got to do right off the bat is create some participants. So I'm going to create some participants here. Just going to name this aid org as aid. Global citizen, going to go ahead and create one of those. And then gov.org as well. And again, the only reason I'm able to do all this is because I'm in the admin scope right now, or the admin identity. So we're going to create those. So now we have one participant of each kind. We don't have any assets yet. So if you remember, we have that transaction for creates project pledge. So let's go ahead and do that. But before we do that, let's do it from the aid ID, the aid org ID, so you can see what they can do with their permissions currently. So to change the ID that you're using, you have this this drop down at the top right. Go ahead and click on that and go to ID registry. So this is where you're able to change what identities are being used in your application or your business network. So in order to create an identity, you first need to create a participant. You need to then bind an identity to that participant, and that's what we're going to do here. So as you can see, we have one existing ID, and this is for the network admin. But let's go ahead and issue some new ones. So for this one, let's just name him aid. And then this has to point to the existing participant. So if I just type in aid, you can see the namespace with the class aid org and ID of aid. And if I want them to issue new IDs, I can give them that access here, but I don't really care if they do or not. So we'll create new. All right, so now we have another ID here, but it says in my wallet. So essentially, when you're interacting with your business network, you can only do it through one ID, so through one scope. And right now, we're interacting as the admin. However, when we do our transaction, we're going to be doing it as the aid organization, and you can do that by clicking Use Now, and then it'll switch automatically for you to be the aid org. But we're not done yet. We're going to create some IDs for the other participants as well. So we're just going to do GC and then GC again for the global citizen, and then we're going to go ahead and create new. And same thing, we got a new ID in our wallet. So we got one more to do, and that's for the gov.org. And then, all right. And there we go. So now we have 4 different IDs that we can use to interact with this business network. So I'm going to switch off from the admin ID to the aid.org now. So there's 2 ways to do that. You can either click use now here, or if you go back to my business networks, you can see we have some new ID cards here to use. So you can just find the ID card you want to use. So here's the aid organization. Just click connect now. And then I'm now interacting with the network as an aid organization. So let's go ahead and test these transactions out. So we can see our own data here. You'll notice this project pledge array here. And what that's going to do is that's going to be a reference to the project pledges that we create. So once we create one, it should pop up here in this array. And you'll see that every participant here has that array as well. So let's go ahead and submit a transaction for our create project pledge. So let's just name it 123, 123, and then our description is 123. And then for the funds, let's do $1,000. So a small project, $1,000 is all they're asking for. And so for the aid.org, what we're going to do is here, this is going to be a reference to an existing participant. So if you recall, we are in the scope of aid right now. That's our ID, essentially, our unique ID. So we just type aid there. So what we're saying here is we're creating a new project pledge with that unique ID of 123, name 123, description 123, and they're requesting $1,000. And this is being requested by this aid user. So we're going to hit submit. What do you think is going to happen? Do you think this is going to work? When I showed you the permissions, do you think we have enough permissions to actually complete this? We do. So now you can see that we have access to actually modify our own resources here. So you can see that this new project pledge has been added. So what I failed to do was actually save my changes when I created the rules. So what was supposed to happen was, let me show you. All right. So now we have those permissions set. Let's go ahead and deploy those changes. So every time you make changes, you need to deploy an update to the BNA file. And what that does is that basically overwrites the existing chain code that's being set, the existing BNA file, with a new version. And so you can see at the bottom left that every time we update, the version number changes to a higher number. So now that we have that in place, what we're going to do is we're going to go ahead and try out another test. All right, so this is going to be 456, essentially the same. And then that's what I wanted to happen. So this is, wait, there we go. That's what I wanted to happen. So this error right here does not have update access to this resource. What does that mean though? That means that we don't have the correct permissions to update our own resources. So I built a rule for that. So I'm gonna go ahead and copy this. I named the rule own resources. And essentially what this rule is going to allow us to do is view our own resources. And it's funny that you have to specify that you even have to have permission to view your own resources in this, but that's how these permissions work in blockchain. You got to be specific and make sure that all the access is required. So that's another thing to keep in mind when you're building these business network definitions. You want to make sure that your transaction, that you have the correct permission set for your transaction processor functions to work the way that we're supposed to. So that's just something to keep in mind. Make sure everything has access and visibility to what it needs to modify. All right, so the next transaction that we need to do is to basically send this pledge to a global citizen. And so the way that works is there's a transaction to notify this global citizen that a pledge is ready, and then they verify it and send it to the government organization. So what we're going to do is we're going to go ahead and give this aid org permission to do that, and then they should be able to basically send this pledge to the global citizen. So now that we have that set, that should work, right? We have correct permissions. I deployed changes this time. Then we can go back to our test and see if this works. So we're still in the ID of the aid organization. So let's give it a try. Send pledge to global citizen. So this global citizen is just with the ID of GC. All right, and then our pledge is 123. All right, what happens when I hit submit? I don't have update access to global citizen. Again, you want to make sure you have the correct permissions to the other participants as well. So in this case, I didn't specify that the aid org can, touch the global citizen's assets. I said that the owner can touch their own assets and basically modify them, but they can't modify another organization's assets. So I have yet another rule to define that. And so this rule is just called aid update global citizen, or aid update GC. And what's important about this rule is it doesn't give everybody access to global citizens' resources. Only the aid org can access global citizens' assets. So also got to remember who you're giving access to. Be aware of that. And I'm only giving update access, so they can't create or delete anything from the global citizen. They can only update the existing participants there with the project pledge. So deploy that, and then now we'll give it a shot and see if that works. So send pledge to global citizen. Global citizen is GC. Project pledge 1, 2, 3, and then now it works. So again, permissions are important to specify and be specific. It's redundant. Be specific with your rules. So now you can see our global citizen has this project pledge. So I'm just going to go ahead and paste the rest of the rules in. It's pretty much the same, kind of the same thing. The global citizen, then they review the project pledge. Once they approve it, then they send it over to the gov org. The gov org then reviews the pledge. They like it, then they can update the pledge and say, yeah, we're going to commit to this. And then they eventually transfer these funds over time to the pledge. So what I'm going to do is I'm going to go ahead and go to this access control list. I'm going to just paste in the rest of the rules. As I said, these rules are going to be in that repo that I sent, or that I linked to. So you can read through these rules little closer and see the details of what's going on. But essentially, I just have a rule for the transactions and specifying who can do those transactions. So again, it's going to be a lot of the same. But before I close out this demo, there's one more thing I want to test out. And I want to show you what happens if I try to do a transaction that I'm not supposed to do. So I'm going to switch over to the global citizen view. And so now I'm participating in this network as a global citizen. And so I can see my resources. I can modify them if I want. But let's try to submit a transaction. So let's say we're a global resource, and we kind of want to create our own pledge. We want to kind of bypass the aid org and see what happens. So let's go ahead and do 3, 2, 1. It won't let me because I don't have create access to this create project transaction. So that was just a quick demo on the transactions and the permissions of these transactions, just to show you how they work. I was getting a few questions on whether or not you can tie permissions to individual transactions, and if you can give access to certain participants and not give access to other participants. So I really hope this clarified some of the confusion about ACL and permissions in Composer. So I hope you all learned a lot about this. So now we're going to see how that works in a dashboard application. So we've got this working in a Composer business network definition, but what about a actual like front end application, a dashboard? So for that, I'm going to point to another pattern that we have. So this one is a little newer. It's a little newer than the global citizen pattern, and it's just this create a customer loyalty program with blockchain. And essentially, this pattern allows you to create a application that has two dashboards, one for each participant. And so you can see how you have multiple dashboards with different permissions for the different users. So that was another question that I had, and this was a pattern that kind of fit that perfectly. So let's go ahead and take a look at this. So for this pattern, I kind of did a lot of the legwork already. I spun up my own network locally, and then I made the changes and deployed the application. But I really recommend visiting this pattern here on the IBM Code site for really going through the steps on your own so you can understand what's involved. So here's kind of a picture, the architecture flow of the application. So we basically have two kinds of users. We have a member and we have a partner. And in this application, it's a customer loyalty program. So the members, they're able to earn points and spend them at all the participating partners' locations. So essentially, these points are going to be available to use at multiple places, although they may only be earned at one store. So it's a pretty cool use case for blockchain, and this application does a really great job of showing you how this use case can be applied to Hyperledger Composer. So on the left side, we have the members that are earning the points. So the first thing they have to do is register to become a member first. And once they register to become a member, they're given access to the network. And then they log in with that, with the access, and they are able to do three things. They're able to earn loyalty points, redeem loyalty points, or just view their transactions. But on the right side, we have the other side of it. We have the partner side, where they're able to just see who's doing what and have a good view of all the people interacting with their application. So they can see who's earning points, they can see who's spending points, and it just gives them a good dashboard to view all of that in. So if you go ahead and click on Get the Code, you'll be taken to GitHub, and they have all the steps here. You can clone the repo and create the BNA file and just deploy this. So for this, you can deploy it locally. You can deploy it on the starter plan on IBM Cloud. For the sake of this demo, I deployed it locally, so we can just take a look at the files and see how it runs. So what I've also done is I've used the playground as well, playground again here, to take a look at the components of this business network definition and see exactly what's going on. So starting with the model file, this is a very simple application. So you can see that there's only two participants. There's the member and there's the partner. And there's only two transactions, earn points and use points. So it's very simple. The script file, we have just the logic for those two transactions. Again, very short, less than 70 lines of code. That's how easy that was. And the access control, although it is a simple application, there are specific rules broken out for the specific participants. So you can actually go through this and see who has access to what. So we have a section dedicated to member access rules. So we can see here the members, they can access only their own account. So again, we're using a conditional rule here to see if they're the owner of the asset they're trying to access. We're also trying to say that members, they don't have access to other member accounts. You want to restrict that to only their own. So there's another rule to define that. And also, we want the members to actually see the participants in the network. We want some visibility there for them to be able to interact with them. So this next rule covers that. And then there's a few more rules covering member access, and then there's another section for partner access as well. So you saw it as a very simple application, right? Only two kinds of participants, only two transactions, very easy. And yet there are a lot of rules defined here. So another great application if you want to learn about ACL and how permissions work in these composer applications. So good place to start. So the pattern basically has you create the BNA file, you use the composer archive create command, create the BNA file, and then you create some cards to deploy this to your network. So if you're familiar with the composer CLI, you can run composer card list. You can see all the cards that I have created. So for this example, oh, did I miss it? Yeah, here it is. I created some cards here to let me interact with the customer loyalty program network. So you can see here I have my admin card. This is the network admin for the card, and I went ahead and created a card for the member and for the partner. So this was all done for me through the web application, and so that's the second part of this pattern. This pattern builds this web application for you that allows you to interact with your blockchain application through a front-end application. And so let me just make sure this is running. All right. And so this is the application. As you can see, it's very simple, and yet it shows us exactly what we need in the terms of permissions here. So you can learn a little bit more about the application. You can register as a member or as a partner. And so what's cool is when you register with this, it actually creates those cards for you. So I'm just going to do that 654, and then I think my keyboard is running out of battery here. And then, so we go ahead and create a new member here. And so behind the scenes, that's going to create a participant in the blockchain network, and it's going to issue them an identity to interact with the blockchain application. So it's fantastic. It does all that for you behind the scenes. And I highly recommend checking the code behind the scenes how this works in the that's linked in the GitHub repo, just to see how all this works. It's using the Node.js composer library to do all these transactions, and it does a great job of doing it. So now we have a account registered. Let's go ahead and log in with our super secure form here. All right, so we're going to sign in. And so now we're interacting with the blockchain network through the eyes of this member. And so this just shows you what you can do here. You can purchase points from any of these partners and then redeem them. So I'm going to create a new partner for this demo and show you how they interact. So when we go to the partners and we register, start with a 0 this time. So now we have a new partner, and this partner is going to be, say, like some store that wants to have a customer loyalty program. And this store, they sign up for an account on here, and they're able to start giving out points to their customers. And then so let's go ahead and let's actually log in as the member first. And so what we're going to do here is we're going to go ahead and just earn some points and then redeem them. And you'll see how this looks on the partner dashboard. So we have to select the partner that we're buying from. Essentially, this would be like an ordering form for some website. But for this demo, they simplified it. So all you do is push buttons. So I want some item Z. That looks good. Transaction was successful. That's great. Give me some of that item Y as well. Oh, I need to select a partner. That's right. So partner, item Y. All right, there we go. So now I've got plenty of points. I've got 280 points. I bought a few things, item Z, item Y, good enough. So now let's redeem them. So I'm going to go ahead and select the same partner that I bought them from, and then I'm going to just redeem them for some cool gadgets or whatever they're giving away. So I like me some item C, so I'll get one of those. Transaction was successful, and then so while I'm at it, I'm going to get me an item A as well for good luck. Transaction was successful. And then so you can see the historian log here of the transactions, the 2 transactions we used to get the points, and the 2 transactions we used to redeem. So now what we're going to do is we're going to change views to a partner and see how that looks on their dashboard. All right. So you can see that the points usage here on the dashboard, you can see how many points have been earned by your customers and how many have been redeemed. And as well, you have full visibility on all the transactions. So it's just a neat way to show different dashboards with different permissions and different through different participants. It's a very simple application, but it does a great job of explaining the permissions and how you can create these unique views for your users. So those were some of the big questions that I was asked in the Slack channel. So that's pretty much all I had planned for. Are there any questions right now? Go ahead and ask in the Twitch chat. I'll be watching it. But yeah, also, if you don't have any questions right now and you want to reach out to me, just find me on the Call for Code Slack channel. I'll be monitoring that and answering questions. There've already been some really great questions there. If you can just scroll through the history and see what people have asked, there's some great stuff there. So yeah, if that's all, then thanks for joining. I really appreciated having y'all here, and look forward to hearing from y'all later.
everyone. My name is John Wallachy, and I am here today as part of our Call for Code series on Twitch. We're doing Call for Code Fridays, and I'm one of the code captains for our Call for Code tech areas. I'm responsible for our IoT area. And so for the next hour or so, we will do we'll talk about IoT, but I figured a lot of developers are interested in drones. And so I decided that I would build, and I've got my drone here. Hopefully you can see that against my background. A drone plus IoT plus visual recognition to, kind of show an example of what you might build with your project. Because we want you to sign up and enter and submit a project for the prize, right? $200,000 is pretty substantial. Get to hang out with some celebrities in October, see a great concert. And so that's will soon to be announced. But I figured we'd talk about IoT and drones, because drones are a fun technology that you might build with. And just as, for example, so recall that you've gone to developer.ibm.com, Call for Code, you've registered yourself. And if you scroll down on our webpage, there are 6 focus technology areas that you might be interested in. I hope that you choose to build a technology or project that uses IoT, because I'm be happy to answer your questions in Slack or via direct message. Reach me on Twitter at John Wallachy. So there's a topic for IoT here. It's collect and analyze device sensor data to take corrective actions. And we've got some code patterns that you can build with. And so I definitely encourage you to take a look at the IoT area. You can build with MQTT. You can build and do analytics with Watson Studio. You can take advantage of blockchain. I wrote a code pattern for IoT asset tracking, use a particle board. And so a lot of good patterns here that you might want to leverage. But let's go talk about drones. And why would drones be interesting? And matter of fact, just last weekend down in Puerto Rico, there was a project that was submitted, and I thought it was absolutely brilliant. And it's actually posted up on YouTube now. You can get to it, and hopefully I'm going to run this this short little intro here.
Right after the hurricane, I was at my apartment, and I was worried for my parents, my family, and my grandma. We had no communications whatsoever. I saw all the destruction. I got more worried. Thankfully, I had my drone, and I visited my parents. They were all right. But my grandma, she was a little further away. The roads were closed. So I used my drones to check on her. She actually waved at me. She was all right. So that's where part of the inspiration came from. In Nahuatl, I saw, first of all, there was a massive destruction. There used to be a basketball court. It was all destroyed. And in the parking lot of that basketball court, there was a message. It had the date. It had messages from family saying, hey, we're alive. There's 0 people dead in this community. We're okay. And you can see all these messages all around the island. SOS messages, water, food. And that's where the inspiration came from. So the idea started with OCR, object character recognition. First of all, I saw the big problem, the challenge of detecting handwriting. And I thought about a way we could standardize these messages. So I started creating a universal language based on icons. And in its implementation, it starts with this mat. Citizens and communities, they could place these mats either on the roof or in their parking lot, on the roads. They could put on the left side of the mat their needs. So, for example, water, food, first aid. On the right side of the mat, you could put the number of people in that household or in that community. So I imagine that if we can make this kit standard and give it to citizens before a disaster, or make it a sheet accessible to them, so if they have only chalk and they don't have this kit accessible, they can draw it out. Then we could fly drones and then recognize them. So the drones, they can be automated, they can collect all this data and process it. During this hackathon, I had the opportunity to learn about machine learning. And in 5 minutes, I was able to upload my images, my custom icons, train the model, and be able to detect and quantify the needs of the citizens. I used the code patterns specifically for the computer vision side. With Watson Studio, I was able to train the model. I realized with technology, we can solve problems. And being able to, for example, machine learning, I have no experience. I'm a self-taught programmer. Being able to create machine learning, create these models in just 5 minutes, that's super powerful. So my grandmother, she passed away right after that. So this is for her, basically, for all the Puerto Ricans who passed through this.
So I thought that was absolutely brilliant. And matter of fact, drones and IoT and visual recognition have been a really fun topic. So now you saw one example that was specifically for Call for Code, but you can imagine some others. So I was recently out at a drone hackathon in Boulder, Colorado. The X-Build hackathon was out in April. And so we got together at Galvanize in Boulder, and we brought some drone experts in. And so I was one of the mentors. And I wanted to tell you about some of the projects that I helped them build. Two of them in particular were relevant to the topic today with Call for Code and with IoT and visual recognition. And so here was a drone hackathon, 25 teams building all sorts of cool drone hacks. Bunch of them, about half of them use Watson in various ways, and two of them in particular use visual recognition. And so this first one, and they were a winner, they won third prize. So this one was Drone Doctor. And so this team, I helped them. They tried to categorize survivors. So they were counting casualties and survivors on the ground from a drone looking down. And so that this team had a lot of fun out in the field on the other side of Galvanize. And they laid on the ground, prone position, sitting and running and standing. And so they were able to take the footage and pass that to a visual recognition service up on Watson and train it, build a custom classifier for casualties and for survivors. And so they built a really fun, a very useful project that as the drone flew over a casualty site, maybe the first responders can't get there, but they want to assess the human impacts. And so this team was really brilliant idea. They started out trying to train for train wrecks and using visual recognition of train wrecks. Well, that was pretty obvious. But what they really focused in on then was the humans, counting the survivors. And then using that data to call for the appropriate first responders. And this is exactly the type of project that you might build for your Call for Code project. So take advantage of Watson visual recognition. Now, the next project was the winner for the best use of Watson. And this project, somewhat related to Call for Code, but I thought it was absolutely bright. So they obviously a drone again, and they were trying to fly the drone on the beach, and they were looking for sharks in the water. And so not shark teeth and sharks underwater. They were looking for silhouettes of sharks. So imagine the drone looking down at the water. You see a silhouette of a shark. So they had a shark class. They had a surfer class. So they trained on surfers. So looking down from the drone at surfers, surfing. And then they had another class for beachgoers. So they imagine the drone looking down, seeing umbrellas and blankets and people at the beach swimming in the water. And the idea with this particular hack was that they were going to look for sharks. And if there were surfers, although they also had a boat classifier. And so drone looking down at boats. And so if the boats were in the water, surfers were in the water, if the beachgoers along the beach were in the water, and there were sharks, then they could send an alert. And they used Twilio to send voice alerts to the beachgoers. And they also alerted the lifeguards. So the lifeguards could take appropriate action to call the surfers in. So I thought it was brilliant. It was a very cool set of classifiers. Well, one classifier with lots of classes, and they wired it together with all sorts of alerting technology and IoT with their drone. And so I thought it was fun. You can check them out. All right. So that was 2 examples of things you might build with drones and IoT and call for code. There's so many more use cases. So imagine you're building a drone tech, and we're going to get to my drone in a couple of minutes, and we'll crash it right in my office here. So how did I go about doing this? So I, was kind of looking around a couple of weeks ago, and I've been following the wildfires out in California, and the devastation is terrible. So I decided that, well, maybe if I had a drone, I could count the number of burned homes and the number of not burned homes. And so I found an article on USA Today, and as I was reading through it, they had all these images of homes just burned to the ashes, devastation, pretty terrible, and it feel for the families affected. And so there was quite a few of these photos. So I grabbed the photos right out of this USA Today article, and I decided to build a classifier. So I downloaded the images to my hard drive here, and I created a little subdirectory called wildfires. And in this, I have 2 directories, one called burned homes, and inside burned homes, I have a set of images from the USA Today article, and so they're just JPEGs. Okay. And then I went to Google, and I kind of Googled around looking for aerial photos of just homes, just drones looking down at homes, not burned, just rooftops. And so I picked a few. If you pick more than 14, 12, you can build a classifier. So that's what I did with aerial directory. Oops. Forget what I called the directory here. Homes area. So there I had a couple of a dozen or so JPEGs and PNGs of aerial photography of drones, of homes, from drones looking down. And so I jumped up to Watson Visual Recognition, and I read through the API and understood how it all worked. And I jumped up to Bluemix and IBM Cloud, and I created myself a visual recognition service, an instance of visual recognition. Very cool thing about Watson Visual Recognition is already been pre-trained on 12,000 everyday objects. It knows about stuff in the real world. You don't have to train it on everything. It's got a default classifier. It also knows foods. And so it knows about 3,000 foods. There's a custom classifier for foods. It's already been pre-built. It's available for you in the cloud, but then you can build your own, right? And so you take your API key and you jump over to Watson Visual Recognition and you paste in your key and you name your classifier. So here I'm going to create a new classifier and I'm going to call it burned homes. And I have 2 remember I took a zip file of my burned home directory and a zip file of my aerial homes, just rooftops. And so some of them are burned, some of them are the negative. So this is not a burned home. So you typically train the service, the neural network, on the object you want and the things that it is not. You can give it anything. And in my case, I gave it rooftops because I wanted to identify the difference between not a rooftop and a burned home. Now, I could think of other ways to do this. You might have a rooftop as a class and a burned home as a class, and just streets or whatever it is as your negative of it. And then, so along the way, I trained it, took about 3 or 4 minutes, and I got myself a burned homes classifier. And so now I've got my custom classifier here, and it's ready to play. Remember, there's the general one. It knows about 12,000 objects, and there's foods, 3,000 objects. It also knows faces, and so you can do face detection with Watson visual recognition. Now I could update my visual recognition service. So as I add more photos, I can retrain my model. In my case here, I'm not going to do that. But I've got it already here, and I just wanted to test to see if it would work. Because if I'm going to send my drone up in the air, I don't want to be fiddling in my office with the tech. And so I want to be outside playing. And so I wrote a little little Node-RED program here. Tell you how this works. And so it's just an endpoint. It's a web page. I'm going to have a form which grabs a URL, which I'm going to paste in. And I take that image URL and I call Watson visual recognition, but I'm going to tell it to use a custom classifier. So I'm going to use burned homes and the default. So here I've got my burned home classifier and whatever unique identifier here. So I pasted that in, and I'm going to get the results from visual recognition, and I'm going to build a little table, and let's go see what it looks like. And so here I had so this is my sample web page. It's not at all fancy. It's just you pass it a URL, which I went out on the internet and I found a burned home, and I'm going to paste it here in, and let's see what Watson finds, if this works. All right, so that was the image. I passed it, and so I did a couple of things. It found a burned home, so that's good. And it also found, in the default classifier, it thought it was an earthquake and a sinkhole and so a light source. So it found a bunch of stuff. But the important thing is that in my little loop through the visual recognition response, I got back a JSON object. Let's see what I got back here. I'll make this a little bit bigger for everyone. Control plus. All right, cool. So maybe you can read that better. So here we had 2 classifiers, and then the first classifier was default, and it found 9 different things. The first one was an earthquake I mentioned, then it was a sinkhole. But more interesting is I'm interested in my other classifier. So here was the burned homes classifier, and I've got one class. It's called burned homes. And with a confidence score of 0.9, so remember, visual recognition only works and most AI works with confidence scores. So the probability is 0.9, 0.7, 0.2, low probability, high probability, or somewhere in the middle. And you have to decide to take action depending on the probability confidence scores. And so in my case, with 0.9 accuracy, Watson visual recognition thought it was a burned home. And so that's pretty cool. So I was able to train my model. All right, so I want to go and do this on my drone now. And so this is where it gets interesting. So my budget was pretty small. And I went out and I searched around. I found a fun little one called the Tello. This is definitely not a commercial for them because it's got some other problems, but it has an API, which I'll talk about. And there's much better commercial drones. You can get GPS, you get other sensor data. So now the other thing you might do with a drone, a more substantial one than just this one, you could add sensors to it. So in addition to video, you can have GPS, you could have CO2, maybe a smoke detector, a particle detector, so how much particulate soot is in the air. You could put obviously temperature, humidity sensors, and you could transmit a bunch of data up to the cloud in addition to the video. So we're going to grab the video frames from this thing, and we're going to see what we can find. All right, so how did I do that? So I picked one. It's about $100. I bought a controller because it's hard to do on your phone. And the way the tech here works, the drone, you power it up in a minute. I'll show you all. It becomes a wireless hotspot. You, in theory, connect your phone to it, and there's an app on your phone. I've got an Android here. And so you connect your Android phone to or iOS device to the hotspot, and you control it up and down, left and right. Great fun. Take it, normally you could just take it, play with it in the yard or at the park, not at the airport. So this one, so that's how it normally works. But it's got so let's go take a look at this because I bought it for a reason. So I was reading through the manuals. I like to read the manual too, that type of guy. And I noticed there's an SDK and a Scratch README. And so I kind of read through the SDK, and sure enough, there's a Python interface to it. I'm like, that's brilliant. It's totally hackable. It's just a UDP port that you can write commands to: up, down, take off, land, up at a percent, centimeters, right? So down particular centimeters, left, right. And so this was kind of cool. Now I could write a program, a Python program, to control my drone. Back, forward, rotate, so you can turn the drone. Yeah, I haven't figured out how to do flips in my office. Probably a bad idea. And you can make it go faster. So this is kind of cool. So now there's an API I can build with. And but painting it, so it turns out Python is while it works fine. I wrote the little sample program. What I really wanted to do was take a look at Node.js. So I'm a Node.js programmer in Node-RED. You notice that I built that little Node-RED sample app, and I wanted to get the data into Node.js. And so it turns out there's a Scratch. I don't want to use Scratch. I want to use Node-RED. But they had a zip file, so I went and I downloaded the zip file, and I figured that was kind of cool. So I, downloaded it, and I put it in a directory here, and I said node tello.js, and it's going to open up a local interface, and I can now send commands from a browser or from Node-RED to the UDP port. Okay. All right. So let's see how this is going to work. And so we're going to have it take off here in my office. And I think we're just going to have it land because otherwise it smashes into the ceiling. All right. So how is that going to work? Let's do this. Because I wanted to capture video from it. So I was fooling around with video here. All right. So now I've turned it on. Hopefully I've charged it enough. There we go. All right. So now it is giving me a blink, and I am going to unlock my phone. And I've got both Wi-Fi and Ethernet on my laptop, so I'm not going to lose you here. So I'm just going to connect to, it should find another interface here. So let's go connect to it. So now I'm connected to it on my laptop. It creates its own little subnet. And let's go connect my phone here. And so now my phone is connected to it. And it's got a fun little app, which I won't use because I'm going to do it from my laptop and we'll crash it there. So there's the app starting up. And so there's the video stream of it, right? I can zoom it around. There's you all, and there's a diploma, and there's me, right? So now we've got video. And so I could just to prove that it works before I figure it out. So I'm going to put it on the floor and slide to take off. And hopefully it's in the frame. I'll see that. I'm going to try and land it here. Hopefully I can land it. Oh, it's going to crash. Cool. So I turned it off. I grabbed it and turned it off. So there's me controlling it from the app, catching some video. And so I wanted to do this from my laptop because, I'm that type of person. And so now I'm going to put it on the ground again and see if I can reach it here. So I'm opening up my interface here. I'm going to click on take off, and then I'm going to click on land. If I fiddle with up and down, it probably will hit the ceiling. So let's go try this out here. So now it's taken off. Hopefully that is still in the frame. And so let's jump to the next one and tell it to land. Really tell it to land here. Gonna catch my head. It didn't land, but I was sending it land commands. And I've got a way to capture video, right? And so now my next big project will be to write a bigger interface around my little drone here, and so I can use Node-RED to control it up and down. I haven't written the Node-RED nodes yet, but certainly next week it'll be a historical little thing. So up and down, and so let's go take a look at. So I was sending it take off and a whole bunch of lands. It didn't land. I don't know why. But you can send it ups and downs and lefts and rights. So I thought that was pretty clever. So that's why I picked this particular Tello drone. There's lots of other drones out there that also have SDKs. So I encourage you to kind of look around, do some research. Ultimately what you want to do is capture the video stream, because now that you've got the video stream, you can start to do some really interesting things with visual recognition, right? And now you can, so in my case here, you can start to look for things in the real world. So let's go see how this works. I've got my little app here. Let's go give it another picture. So my favorite. So we could give it, that's a pretty tricky one. So this one sees a home burned and not burned. And so let's go copy that image URL, jump over to my little test app here and paste in that URL. I don't think I care about the width. And let's go see what my visual recognition service thinks it is. So with 0.94 accuracy, it saw a burned home. So that was kind of fun. I used visual recognition. I used the drone data. Now, I would love to take you outside and drive around fly over my house, take a picture, and my house is intact, so it would classify as not burned, and so that would be a good thing. But the Twitch doesn't really let me do that. That would be a big adventure for us to all pack up and go outside. Maybe next time we'll do that. But so now we've got the building blocks. And what I encourage you to do next is think about how you might take these building blocks and create a project, right? A call for code project. Because ultimately, that's where I want you to head. I want you to take advantage of drone, visual recognition, some sensors here. The bigger drones, you can mount Raspberry Pis. Maybe you could just Raspberry Pi pretty heavy. They're not, so you all know what a Raspberry Pi is. It weighs a couple of ounces and stuff. Probably more than you need, because you could take one of these. So this is a Raspberry Pi Zero, and you could put a Zero with a camera. I've got I don't have my Pi camera around, and you could. So this is pretty light. So that's an ounce or so, and with the camera, which is behind the green screen, you can connect your Pi camera to it, and then of course this too, you can connect to Wi-Fi, and then put this on a drone, maybe a little more substantial than this one. I don't know if it would have the lift capacity to fly, so I could replace or add to a drone, and then start to think about projects. So I just encourage people to brainstorm and do some design thinking, whether it's survivors or sharks or burned homes or wildfires. If you can think of a way to assist in the recovery after a natural disaster, talk to a first responder, get some firsthand experience. What you will often find from first responders is the situational awareness of, where are the assets? Where are my people? I've got, whether it's forest fire and you're trying to track your firefighters, maybe it's you're trying to, in other types of natural disasters, you've got emergency response teams and medical teams. You want to track where they are. You might use an asset tracker, right? So in this case, this is a particle electron, and it's got some sensors. It has cell towers, so talks to the cell towers. Obviously, in a natural disaster, they have to be there. So that was the problem with this type of technology in Puerto Rico. All the cell towers had been damaged. But the idea with this one is you can send data to the cloud over the cellular network, small little data plan, unlike your phone where it's got 20 gig, all you can eat stream video, and Netflix. This one has a very small 5 megabyte data plan per month, and it just sends sensor data and it figures out. So you could do GPS, you could do cell tower triangulation, and then with GPS plus your sensor readings, get that data up to the cloud so you know where, what, and when. I actually wrote a code pattern that helps you do that using blockchain. So you can write your data to blockchain. And I've got so they all, yes, you could easily identify each drone. You could have a series of drones, out in the field. I've seen mesh networks. You'd have to get maybe a more substantial drone than this one, but you could build a mesh network of drones. So if the communications networks are down, the cell towers are broken, but in a mesh network, the concept is if this Wi-Fi can talk to the next node in the mesh, which can talk to the next node in the mesh, and so you can extend your network to much further than you might elsewise. And in this case, you could build a mesh network of drones that to link pretty far. You also could use sub 1 gigahertz that has an extended range, couple of kilometer range, depending on the atmospheric conditions and obstructions. But sub 1 gigahertz is a good way to extend the range of these types of devices. This one here is Wi-Fi only, so I think it's got a distance of about 100 meters. It gets that far from me, I can't see it. The wind blows it, lands on a roof. I buy a new one. But the more substantial ones have much greater range. So Wi-Fi or sub 1 gigahertz networks, LoRaN, and cellular networks are all good ways to control your drone, get the sensor data up to the cloud. In this particular case, I wrote it here. I was tracking medical supplies across Puerto Rico, and I watched as I drove a truck, and of course the truck was breaking down, and the refrigerator was going to bad. I was trying to send medical supplies across the island, and the refrigerator was faulty. So I was getting temperature readings off of my IoT asset tracker. So those are the types of things you might build with your Call for Code project, with drone data, with visual recognition data. Do encourage you to brainstorm. I thought it was clever what the drone hack team did here. They, their classifiers, and then the sharks, right? The sharks are another good fun little story that they were able to tell. In your Call for Code project, you want to be able to tell a story about how you're going to use your drone with IoT, with some of the Watson services, so visual recognition, calling out to push notifications to all the first responders. Then come back and do some training. So think about your classifier and your training set. So the important thing about training with visual recognition is give it a good training set. So here in my case, I just hit Nautilus here, and I had a good set of so there's my training set of burned homes, and then I had a training set of aerial photography for my just regular homes in houses. Okay, so yeah, so obviously here I only picked a dozen, right? I only picked a few. I didn't spend a lot of time in my little sample here. I just built this morning for you all. But you obviously could do a much more substantial training set. 50 to 100 probably is plenty. I wouldn't go more than that. And then let visual recognition build a neural network for you. Okay. So that's a little story about visual recognition and IoT. Take advantage of Node-RED. And so here, you could obviously build a better website than me. I kind of just chucked this together. And I kind of just looped through the JSON object that gets passed back from visual recognition in message result images. I get an array of objects, and then I can loop through. And so this was nature, and the next one was, I'm looking for that sinkhole. Where is the sinkhole? Oh, there's the sinkhole with 0.5. It thought it was a sinkhole, whatever image we were looking at there. So you could obviously train it to do better. And but I trained it on the burned home, and that's a pretty good response there, 0.9. And we can go out on the internet and find other burned homes and see what it looks like if we wanted to. So, so Mike, I've kind of exhausted myself on drones and IoT. Hopefully folks are thinking about their projects. If you've formed a team and you want to build with IoT, find me in Slack at the Call for Code workspace. There's an IoT channel, and you can ask questions. I'm monitoring that particular channel. You can, whether you're building with drones or building with sensors or building with Raspberry Pis or Arduinos or any other sensor, I've got plenty of them around. I can help you build with those, and then work with you on your project, right? Come up with that really cool how to help save lives. And that's what we want you to do with Call for Code. All right, so Mike, we'll wrap up here and just encourage everyone to keep going and register for Call for Code. John Wallachy signing out.